The study of Vachellia ceale. Vachellia ceale is a thorny plant of the Senegalese flora, formerly called Acacia ceale. For a better recognition of the plant, we present here in figure 1 the trunk of Vachellia ceale, and at figure 2 the leaves. The roots of the plants are used to treat asthenia, diarrhea, dysentery, stomach ulcer, and nervous disorder. In case of colic, we can use the leaves, and the fruit are indicated to treat toothache, stomatitis, and gingivitis. The aim of the study was to determine the main chemical families present in an hydroethanolic extract of Vachellia ceale trunk bark extract, and to evaluate the antioxidant activity of the extract. As specific objectives, it was about to extract the dry roots bark of the plant, to carry out coloring and precipitation reaction in tubes, and to determine the 50% inhibitory concentrations of the product to be tested. To achieve these objectives, we used these material and methods. For the plant materials, it was about root bark of Vachellia ceale. We use also some equipment laboratories and some reagent and solvents. For the extraction, the powder of root bark of Vachellia ceale were extracted by a mixture of water and ethanol in percentage 80% of ethanol and 20% of water. After filtration, we obtain an hydroethanolic solution that was evaporated to obtain a pasty extract. At last, we put the pasty extract in a desiccator to obtain a dry extract. We perform a chemical screening with the dry extract, and the chemical chemical researches was the polyphenol with the reaction with ferric chloride, flavonoid with the reaction of Shibata, tannin with the Chesney reaction, saponin with the determination of the form index, anthracenozide with Bontrager reaction, alkaloid with Walsermeyer, Bouchard, and Dagendorf reagent, sterol and triterpene by the Lieberman-Bouchard reaction, coumarin by the fluorescence in 366 nanometer in ammoniacal medium, and cardiotonic glycoside by Balger and Ked reaction. About the antioxidant test, we used the ABTS test, and it was at first to regenerate the ABTS reagent in a solution. Secondary, we have performed a dilution series of sample to be tested. So we have 6 concentration to be tested from 0.33 to 10.69 microgram per milliliter. After we mix 1.5 milliliter of ABTS solution with 50 microliter of product to be tested at different concentration. So at last, we read the absorbance at 700 nanometer. This methodology allowed to obtain the following result. We start by the extraction yield. We obtain a yield of 29.84 by extracting 50 gram of root bark extract powder. The result of the phytochemical screening, we have detected polyphenol, condensed tannin, flavonoid, saponin, and sterol and triterpene. about the antioxidant activity test, we notice it here that the inhibition percentage increase according to the concentration, with a better inhibition for the ascorbic acid. But we notice it too that at lower concentration and at higher concentration, the two activities are comparable with a significant difference. This is confirmed by the determination of IC50. IC50 means inhibition concentration at 50%. Lower is the IC50, greater is the antioxidant power. So here we can see that acid ascorbic is more effective than the extract, but the difference, there's a little difference with a significant difference. In conclusion, our extract presents several chemical groups, including polyphenol. Free radical scavenging activity is comparable to the acid ascorbic acid. The antioxidant activity could be due to polyphenol. Donc, follow-up studies could lead the way to isolate and identify the polyphenol compounds by spectroscopy methods. And for the plant preservation, we need to rationalize the exploitation of roots, because roots are vital for plant. And we have to think to reforest again. Thank you, ladies and gentlemen.
Thank you for this kind of presentation. One question?
Okay, thank you for your good presentation. I would like to know what's the difference between polyphenol and flavonoids.
Flavonoid. Yeah. Flavonoids are part of polyphenol. No, there's a general reaction. The general reaction is done by FeCl3. Okay. Before at the beginning of the world, we search first if they are polyphenol. If they are polyphenol, we search again, secondary, if they are tannin are polyphenol. If they are flavonoid are polyphenol.
So two different tests for flavonoid and polyphenols.
Is the general test.
Tests are different.
Different.
But you mean that they are similar?
No. Flavonoids are class of polyphenol.
Okay.
Flavonoids are class of polyphenol. As tannin, as class of polyphenol.
Thank you for your presentation. So, our last speaker is absent, Alioune Diallo. So, a little bit change, please. I will call Mohamed Lamine Sol.
Mohamed Lamine Sol.
Ababakar Diouf, sorry. Ababakar will tell us about analysis of soil pollution by lead in automobile garage in Dakar. It's okay?
Hello, dear
You have 10 minutes.
Okay. Hello, dear moderator. Good afternoon, ladies and gentlemen. My name is Ababakar Diouf from Organic Physical Chemistry and Environmental Analysis Laboratory, Sheikh Anta Diop University. I'm going to tell you about my subject, which is analysis of soil pollution by lead in automobile garages, mechanical and road in Dakar. The order of the presentation is as follows: introduction, material and methods, results and discussion, and we finish by conclusion, perspective, and recommendation. By way of introduction, pollution can be defined as a topical issue affecting virtually all natural environments, including the soil matrix. Among the major pollutants in the environment are heavy metals, which can cause serious problems through their toxicity and potential bioaccumulation in living organisms. Some of these heavy metals, such as lead, which is the subject of our study, are discharged into the soil of mechanical and road geodesics through their combustion and vehicle repair activity. According to WHO and US EPA, the main toxic heavy metals involved in soil pollution are copper, mercury, lead, cadmium, nickel, chromium, and zinc. The lead considered in this study was selected because of the toxic property it commonly exhibits in the current state of soil contamination in geodesics. Ingestion or inhalation of this metallic trace element can lead to health problems in humans, including anemia, kidney complication, and disorders of the nervous and digestive systems. Nevertheless, lead plays an important role in the local economy, especially in the automotive sector. However, intensive use and mismanagement of lead are responsible for increasing its concentration in the soil of care geodesics. The result is the contamination of these natural environments. The aim of this work is to monitoring soil lead pollution using X-ray fluorescence spectrometry. We were able to carry out a preliminary study on the basis of interviews with people qualified in the road sector. However, sampling was carried out during the dry season in March 2022. In the southeastern part of Dakar, we visited Demdik Terminal Palais 2, Petersen, and La Dior bus stations. In the central zone, samples were taken from mechanical geodesics in Mermoz, Dalifort, the Iba Mar Diop Stadium, the Beaumarais train station, and the Demdik Terminal at Liberté 5. After sampling, the soil samples were placed in plastic bags. Here is the analysis protocol from soil pellet formation to X-ray fluorescence analysis. So we wiped out 1.2 grams soil and mixed it with binder. The mixture was then placed in the 25-ton press, and the result is a soil pellet ready for fluorescence analysis. And then the results show the presence not only of lead, but also of other toxic metals such as arsenic, chromium, zinc, etc. This table shows a variation in lead contents in different geodesics. So lead contents ran from 36.62 to 53.26 ppm. And lead levels are higher in mechanical geodesics in Mermoz, in mechanical geodesic soils than in bus stations soils. The difference is due to the fact that bus stations are more regulated than mechanical geodesics. Moreover, geodesics are not really specialized. This table shows a correlation matrix between geodesics, where mechanical geodesics correlate perfectly with each other, while the bus stations shows a strong correlation with control site. Finally, the results show that lead levels varied between the different care geodesics, and that values were higher in mechanical geodesics than in bus stations. Lead levels range from 36.62 to 53.26 ppm, with a detection limit of 2 ppm. The lead levels found are below the US EPA warming level of 400 ppm. Soil does not present a major health risk for motorists or mechanics, but long-term exposure could adversely affect children living near these areas. In prospect, We plan to synthesis of electrochemical sensors capable of detecting lead in soil, well water, and tap water near mechanical garages in the most polluted regions of Senegal. We recommend that automotive service and repair shop operator take care to implement an effective environmental prevention policy. They need to reduce the pollution caused by their activity and set up efficient waste management systems to promote recovery or disposal in the best possible condition from an environmental point of view. This waste must be mixed together. It must be sorted and packaged separately in the garage with pile contentment to prevent any risk of accidental spillage. Thank you for your attention.
Thank you for this kind presentation. One question?
Thank you very much. Could you please go back to the conclusion? Yeah.
Oh.
Please, no,
The last.
the last one, yeah. Please, what is the link between your conclusion and your perspective here?
The link.
The link, yeah.
But in conclusion, I explain why the lead can favorite the health risk in mechanics in motorist or mechanics. But in prospect, we plan to synthesis of electrochemical sensor capable of detecting lead in soil or water or water and tap water on tap water.
But I'm not sure because
Sorry.
Thank you. There's another method to detect lead, I think so.
Okay. Thank you.
Just question, please. For your detection, you use fluorescence?
Repeat.
The detection, the method of detection you use?
Detection, the fluorescence the X-ray fluorescence spectrometry.
Okay, okay. So thank you again.
Thank
so
you.
before concluding, I want to thank all our speakers and declare our section closed. Thank you for your attendance.
okay, different session.
nga xool ndax waaw moo gën a wóor na du ko moo gën a wóor bii la ok moo war a dem léegi mën naa ko bàyyi wala ok après ok après
Can I send you my presentation?
yeah you have a USB key or
Email.
in email
Yes.
you don't have USB key
What is that?
USB key like this
It doesn't. Maybe
this kind of come
Type C.
yeah
Okay, I can bring it with you. I have a adapter.
okay attends je vais voir le programme.
Oui, j'ai vu dans le programme qu'il y avait une conférence plénière.
Oui, sûr. C'est une groupe, tout ça.
Ça c'est déjà fait.
Oui, oui, ça c'est déjà fait. C'est-à-dire c'est Tuesday, Andossa, digital. Normalement, on passe par ici. Et c'est ça.
Donc on commence directement par celle-là.
Oui, par celle-là.
Il n'y a pas de conférence plénière.
Je pense pas. Je pense pas.
Parce que dans le programme. Ici, là.
Il y a une plénière pour Vincent. C'est ça.
Non, je vois ici celle-là.
C'est déjà passé, je pense.
Non, c'est pas passé.
Ah oui. Mais c'était à 14h.
Non, mais vu qu'on a commencé
Avec les présentations.
Ouais.
Hein?
Donc là, ceux qui ont mis leur.
Ouais, on parle.
Ceux qui ont mis leur présentation, c'est lesquels en fait?
Hein?
Ceux qui ont mis leur présentation, c'est lesquels? On va commencer là.
Je vais mettre mon pointeur à disposition.
Oui, c'est ça, parce que nous avons le quoi.
Yes? From your laptop? Okay. Elle présente avec sa machine. Est-ce qu'il n'y a pas de clé ou on prend un message? Oui, c'est non, mais moi j'ai pas de clé.
Excuse-moi, récupérez la présentation.
C'est une clé. Clé présentation. Non, ça c'est la clé du pointeur. You can change your name. Put your name in the presentation. Africa.
You will present after.
No, I think there is one person before me.
Ok.
Présentation. Non, sa présentation.
Ok.
Demal si clé, sama clé.
No, it's
Which one?
it's here. Go down, yes. Shaima Hikal, this one, yes.
That's okay.
Okay. Wait. Ok, go. Yeah, c'est bon. Elle va présenter maintenant.
On va attendre.
We will do a presentation now.
Yeah, it should be this time. Should I start?
No, you have a plénière présentation.
Yeah, I think.
On a une présentation.
We have what?
have a plenary presentation.
It's me. Should I wait here or? I go back? Okay. So, will I be able to see the notes in the presentation?
Yeah.
I will see the notes here, but not
Yeah,
here.
yes. Yeah, you will see together.
No, I want to see the notes here, but not here. Notes.
Here and not here. Okay, the no.
Notes, yes.
Okay. It's like this.
No.
You do some note in.
This. I want to see this. But let me just edit this because you know why when I am presenting, I want to see this.
Yeah, let's take.
It came differently.
Let's take to see if it's
Okay. Many things.
C'est bon. Your attention, please. Your attention, please. Yeah, let's welcome Shima Ekal. He's a Elsevier life science subject matter expert, supporting the growing base of institutions in the life science fields, including chemistry, biology, medicine, and pharmacy, using Elsevier solution. And in her current role, she works on retaining, developing, and expanding current Elsevier partnerships, enhancing partnerships value, and ensuring smooth subscription through holding capacity building programs on solution and research skill. Shima has lectured more than 300 workshops and seminars
on research tools, writing, publishing, and ethics in partnership with universities, governmental institutions, and research societies. Shima has a strong academic background. She holds a bachelor's in pharmacy, 2 masters in biotechnology and health and public health, and currently she is a PhD candidate in global health at the American University in Cairo. I'm going to leave the floor now to Shima to introduce us, her presentation called Unlocking a Sustainable Future with Green Chemistry Approaches. All right, the floor is yours, Shima.
Thank you. So good afternoon, everyone. I am Shaima Heikel, the subject matter expert for the life science solutions in Elsevier. And today I came together with my colleague Sherif Ghazi, the account manager for the life science solutions. And I will talk about green chemistry and how to unlock the sustainable future with green chemistry approaches and how Elsevier can support researchers in this field. So to start, I wanted to show you an overview of the chemistry research output in Africa. These are insights we got from SciVal, a tool provided by Elsevier as well. So if you can see here, you will find that chemistry contributes to more than half of the African research output. So this is the research output of whole Africa, and you will see chemistry is included in many topics and many fields. And this is the research output that we have in Africa since from 2018 to 2023. And if we went and we measured or we compared the impact of this research output, the chemistry research output in Africa, compared to the world research output in chemistry, we'll find that during the last 5 years, the impact of the research in Africa or coming from Africa is even increasing or exceeding what's happening in the world. So in Africa, researchers are contributing a lot to chemistry, especially in the last 5 years, and the impact of the research we're doing is increasing. That's why we wanted to talk about one of the trends in chemistry nowadays, which is green chemistry, because now it's one of the hottest topics in chemistry overall, and it's the time for doing green chemistry. So what is green chemistry? As I told you, green chemistry is a hot topic nowadays, and it's related more to the sustainability and what's happening in research. And green chemistry refers to finding alternative methods for producing particular molecules or doing production, decreasing the waste of any synthesis we're doing, increasing the yield, having more safer alternatives or options. And it's a hot topic now because we're in the era of the climate change, the global warming, and having these side effects is not solvable. So we have to find solutions to even avoid these problems before happening. That's why the UN is now focusing more on doing green chemistry in research. And we have these 12 principles of green chemistry that supports researchers or encourage researchers to do more greener solutions and find more alternatives that would support in having sustainable chemistry, producing chemicals that are used to achieve the green chemistry concepts, and also help achieving the SDGs, the 2030 SDGs. From here, we can go to the SDGs themselves. So we know also it's a hot topic, and all researchers now try to contribute more to the SDGs. And actually, green chemistry is one of the concepts that relate to many of the SDGs, so at least 7 or 8 SDGs are related to green chemistry, or green chemistry can help solving 7 to 8 SDGs, including SDG number 3, which is health, SDG number 6 about clean water and sanitation, SDG number 7, 8, 9, and so on. So working on green chemistry or adopting green chemistry solutions would help researchers first working in one of the hot topics in chemistry, and also solving or achieving one of the SDGs, which is also very helpful for even the impact of the researcher himself. Going back to Africa, I wanted also to show you one of the examples of how Africa or the African researchers are contributing to SDGs. So I chose the SDG number 6, clean water and sanitation, because it's one of the topics that's very important for us in the African continent. And you will find that all the African countries are contributing to SDG number 6. And the contribution is divided. So all the countries are contributing, or you'll find the research output from everywhere in Africa. However, some countries are leading this contribution to SDG number 6, including Egypt, South Africa, Nigeria, Ethiopia, Morocco, Algeria, and so on. So these are the top 10 countries leading this, the research output in this field. So why we're doing all of this, we're saying all of this, because as I told you, so now the UN, the United Nations, especially the United Nations, the UNEP, the United Nations Environmental Program, they are focusing a lot on encouraging researchers to do or to contribute to green chemistry. And now there are 10 objectives from the UNEP for green chemistry and sustainable chemistry to help achieving the SDGs, and also contributing to more finding safer or alternative solutions. These objectives are to promote the innovation and unveil the full potential of chemistry, and they include minimizing the chemical hazards, avoiding regrettable substitutions and alternatives, sustainable sourcing of resources and feedstocks, advancing sustainability of production processes, advancing sustainability of products, also minimizing the chemical releases and pollution, enabling the non-toxic circularity of products, maximizing the social benefits, protecting workers and consumers and vulnerable populations, and also developing solutions for sustainability challenges. Now, we knew what is green chemistry and how green chemistry is now a trend in the world of research. I want also to show you how Elsevier is supporting these initiatives of green chemistry, and how we're contributing to the green chemistry research overall. So currently, Elsevier is providing support to researchers working in chemistry overall, and especially in green chemistry. So we are doing, we're having this initiative to support many researchers worldwide, and the research group, the big research groups, was in the projects related to the green chemistry. One of them was this project that was done with the University of Cambridge in UK. And this one, actually Elsevier worked, or the team of Elsevier worked with the young researchers at the University of Cambridge to develop sustainable synthesis routes. So find routes for synthesizing new or even existing molecules, but with a greener way, like increasing the yield of the product, decreasing the waste. Many researchers working on finding data, especially the AI data or AI generated data, to be able to manufacture paths that integrate the biomass and the bio-waste into the chemical reactions, so that they can get or generate value-added chemicals. Another initiative was done with the University Nacional de La Plata. It's a university in Argentina. And this one was also, Elsevier helped the researchers there, featuring the data they can use or they can find to find novel solvents and reagents, catalysts, and more renewable energy sources, so that they can have or they can generate or build better reactions for a sustainable future. And actually many more, so we're working with many institutions worldwide to encourage the researchers working in this field and then support them with all the information they need so that they can do their reactions or their projects. That's why we wanted to come and meet you and talk about what we're doing and how we're helping researchers in green chemistry especially, and in chemistry overall. And we also, as Elsevier provides a tool which is Reaccess, that's designed to help or to support researchers, students, and postgraduate students in all the research fields related to chemistry. This includes supporting the educational process, supporting the research process, and also helping in decision-making process. Going back to the green chemistry, now I want also to highlight that part of the green chemistry is synthesis. And synthesis is one of the major contributors or the most important processes in the chemical production. And how can we unlock the sustainable future with this green synthesis, our green chemistry synthesis? So a closer look on green synthesis or in chemical synthesis, nowadays, or the trend now is that we can build a sustainable future with one synthesis at a time. How to do that? So chemistry now can drive the sustainable change through adopting different tools in the synthesis. For example, seeking new sustainable routes for production of a new compound or even an existing compound, and also modifying the existing routes so that they can provide more safe chemicals or safer chemicals. How to do that, or how can we make the chemical synthesis processes more efficient and sustainable? These are different steps that would support researchers doing this. So first of all, accessing the depths of sustainable chemistry research and build a knowledgeable network. The second thing would be to keep the pace with the leading research and researchers in the field, and then leverage the existing literature so that we can, and the recent patents, so that we can find more greener synthesis ways for compounds. Identifying the toxicity and bioactivity of chemicals is also essential so that we can avoid developing chemicals that have high toxicity profiles and then produce chemicals with lower side effects or toxicity, and then discover the greenness latent in the existing knowledge. And this step is very important because in many of the steps we're having or the knowledge that we have, there is greenness in these compounds or in these reactions, but we're yet to discover them. The last thing would be to facilitate the inter and multidisciplinary research to unlock the dimensions of the green chemistry. And this is how we can support, or Elsevier can support with our tools. So first of all, to start doing research in green chemistry, we will need to get a wider background or a broader idea of what's there in the research or in the literature. So that would happen through exploring what's published from different publishers or in the recent articles, and that's how we can use the interoperability between Elsevier tools to find out what was published in the research, what is the hot topic now, what is the trend, how to make the, if I'm interested in one compound, what was published about this compound, how this compound can be synthesized with a greener way, and then I can go from Science Direct, for example, to explore what was published, everything that was published, and then I go more specific to know the properties of this compound through a chemistry database or through Reaccess. The second step that would help me is that I know the key players in the field. So to know the key players in this field, it's also possible through exploring a database like Scopus, understanding who are the researchers that are playing an essential role or a crucial role in this field. And then I start understand what are the methods that they adopted, what were the use cases that were successful with them. And from this, I start either following what they did or do collaborations with the key players in the field, especially if they are from the same continent or the same country or something like that. And I can also go from the broader perspective of Scopus, for example, and then I select what would be the molecule that I want to work on, and then I go to a chemistry database for more advanced or more technical properties or information. And then after I knew I got the bigger picture about a topic or an idea, and then I knew the key players in the field. Now comes the concept of applying what I learned to start getting a product. And to do this, synthesis is a key. And as we know that currently we're in the era of AI, using artificial intelligence to support our research or to support the knowledge we're having. That's why AI is also now coming, especially for synthesis, because now we can also use the databases like Reaccess, for example, to start predict new routes for synthesizing a compound. So it's not now only about trial and error. Of course, trial and error is something that's valid and we have to do, but now we can also use AI to start predicting routes that would be very efficient for increasing a yield of a compound, go more green in synthesizing or producing something that we're interested in. So at the end, we will get the product that we are targeting through using the AI and then trying what the AI predicted or got learned from other reactions that were done before, and then we start applying this and then get our green molecules or green products. And in the synthesis also, we can look at many things. It's not only the yield. So we can try to predict if the starting materials will be there or not, are commercially available or not. The cost of the synthesis itself, if we're doing a production chemistry. Maybe also need to check the bioactivity or the bioavailability of these products and the toxicity profiles, and we'll talk about this now. Many things actually, and then the yield of the reaction. Yeah, so the green chemistry and synthesis would apply in many ways, and the idea is that we can find, even for the reactions that we know, we can find more greener ways for these syntheses. The fourth thing that I just mentioned would be so after I knew that I am going to synthesize this compound or work on this compound, one step that would be very important is to check the bioactivity of this compound, especially the toxicity profile, because currently, or the green chemistry concept would include that when we synthesize one compound or when we develop a new compound or even a known compound, we decrease the toxicity as much as we can, and instead we go for the safer molecules, because that would help us in decreasing the contamination in environment, contributing to environmental safety, and many, many concepts. So checking these information is also essential for chemists. And this would be also applicable when you're using these concepts or these steps, when you're following the steps. So you can, when you synthesize a molecule, you can check the target and bioactivity data through the database, find the information, and then start to decide whether this molecule should be produced this way, or you should follow this reaction or not. Using also a chemistry database would be helpful in the case that you have information in mind, you know, properties about a compound, or you have in mind specific points related to a reaction, and then you want to find the reaction where these points apply. Or you know the properties of something, and then you want to find the molecule where these properties apply. So it also works like the other way. If you know the information and then you want to find the molecule or the reaction you're targeting, you can also do that. So you can start like from the vice versa. And this is what was happening in the University of Cambridge project. So they started to apply what they have in mind regarding the reactions, what they want to do, or they want to address from the reactions that they are going to apply or produce. And then they can enter the information they have in mind to the database, and they start to find what should be the steps or the experimental procedures they should follow to find out the products they want. The last thing would be that, or finding all of this information in one place would be very easy with Reaxys. Reaxys is a chemistry platform provided by Elsevier, and it helps researchers finding all data about green chemistry and about any chemical topic overall. And then it also helps researchers finding the recent patents in a field, so you can explore what was happening, what are the trends in this topic, what were the patents published, what's there in the literature, and then find all the properties of any compound, start using AI for doing synthesis, and then also check the bioactivity and bioavailability of any compound. We will talk more about Reaxys, our database, in another session. So wait for that. And yeah, thank you. If you have any questions, please let me know.
All right, now is the time for questions. And if you have some question, please. Maybe I could make a small summarizing for people to refresh them. You talk about the first thing is how this gives some publications on this green chemistry and how the African countries are contributing to this interesting topic, and also, oh, sorry, thank you. And also, I think you talked about green chemistry. And also, she talked about green chemistry, how it could help, research nowadays, and by giving the example of SDG 6, and also she talked about green chemistry and sustainability, giving 10 objectives that are very interesting, and then talking about how Elsevier support, this green chemistry to be more understandable among the researcher. And also she talked about, sorry. You have a question? Okay, question, okay.
Hello. Thank you. Thank you for your presentation, which is very clear and which have a lot of information for us. One of my topic is related to green chemistry. I am working in my second topic related to synthesis of biodiesel. Biodiesel from transesterification of jatropha. We have a real problem. We can synthesize it here because we have a lot of jatropha here in Senegal. In the middle of Senegal, we have a lot of jatropha. So synthesizing jatropha is very possible here. But we have a problem of characterization. Yes, we have to characterize our biodiesel. It's very, very difficult. We are allowed to have partnership with others in Europe, in Deutschland, like something. Green chemistry is a topic which is very interesting for African, because in Africa we have a lot of vegetables. But the real problem is our laboratories here in Senegal are somewhat very, very poor for the characterization. In what kind we can cooperate together in order to try to improve, to find a solution to this problem. For example, characterizing what we are synthesizing here in order to replace petrodiesel. Thank you very much.
Thank you, Professor, for the question. I agree with you. Green chemistry concepts are now very important, especially for the African continent, because we have many resources we can use. But yeah, this is the idea. So because the finding the machines themselves would be maybe a challenge. That's why collaboration is a key, and I was talking about this collaboration between countries inside Africa or even outside would be a key. Definitely we can support in this, so we can talk about this later, how we can help you in this. But also the idea of having such a great scope of, or a broad scope of information, and using AI both would help you maybe find, more or less expensive ways for doing the characterization. I can show you when we're done how to do this, or if we can find research that was done with from another group that used less costly ways for the characterization. What was the characterization that was done for a similar compound of mine? Because now we have like a dense information in the literature, but the idea is how to find this information. So maybe you can search for your compound first, if there was something like that, and what were the studies published about that, or similar compounds, and then you start getting an idea of what to do, and you can select like the least cost of these. If you didn't find anything that was published about even a similar compound for yours, we can start looking for the key players in the field, as I was showing, and then when you find the key players, you can start looking for ways for collaboration. And collaboration is now something that is very important in research, and also the multidisciplinarity, because you don't have to work with chemists. You can increase your collaboration or widen your collaboration to work with biologists in Africa or even another country. So something like that would help, and we can support you in this. Any other questions?
If not, let's thank Shima for a great presentation. Thank you.
Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you. Thank you.
Now, please, we have a great delay, so we want to move directly to the parallel sessions. But please, there are some confusion because some persons do not look at their room and make this confusion. So those who have to present at Digitata should move at Digitata. So those who have to present in Adansonia remain in this room. Okay? So I think it is green chemistry or something like that. The second.
Yeah, I think also issues with attribution and additionality and measuring impact when it comes to blended finance. Thanks.
Come on. You have to share this.
You have your presentation. You have your presentation into the USB key. Your presentation.
No, I'm not.
Okay.
Yeah.
Okay.
Now we will start the second session for oral communication. Dr. Duggar will do his presentation tomorrow because he is not available today. We will have Dr. Meyama. He will ask us about supramolecular solvent, based liquid phase, micro extraction of sulfonamide in tomato juice, followed by high performance liquid chromatographic assessment of the greenness profile using analytical echo scale, agree and agree play. You have 10 minutes for your.
Thank you, Chair. Good afternoon, ladies and gentlemen. As already stated, I'm going to be talking about supramolecular-based liquid phase microextraction for the determination of sulfonamides in tomato juice, followed by the green assessment of the developed method. So I'm quickly going to take you through the background before actually discussing the research findings. So what are antibiotics? They're simply chemicals or substances that are used to kill or inhibit the growth of bacteria. Actually, huge amounts of these antibiotics are used by both animals and human beings in curing diseases. And in livestock farming or in animal husbandries, lots of amounts of antibiotics are used to promote growth, to cure diseases, and also to prevent diseases. In the EU countries, the application of antibiotics for preventative purposes is prohibited. So the big danger in this, especially in in animal husbandry, is that if withdrawal or inappropriate or adequate withdrawal times are not observed, we end up in residues in food that are destined for human consumption. Food like the milk, the eggs, and also the animal tissue, which may directly affect consumers in a negative way. So I will be focusing on sulfonamides. There are various examples of antibiotics that are used in in animal husbandry. So for this particular presentation, I'll be focusing on sulfonamides. They are synthetic antibiotics, and they are mainly used in animal husbandries because of their low cost. They are broad spectrum activities, and they are very effective as growth promoters. And if you look at the research or number of papers online, the metabolites are found in aquatic environments. So how do they end up in the environments? Sulfonamides or other types of bacteria, they reach the environment by direct excretion into the water or the land by humans or animals. They also can reach the environment by direct application of manures, and they can also be discharged by the wastewater management treatment plants. And the big danger in this is that, like, if wastewater is reused in food irrigation, these can be a danger for the agro ecosystem and also for food, because like with plant crops, you know, where wastewater is used for irrigating this crop, so that might be a problem. So there are a number of countries where they have set maximum residue limits, including the European countries, America, and even where I come from, South Africa. But unfortunately, there are no maximum residue limits in food crops. So it is very necessary to develop methods that will be able to determine these antibiotic residues in food samples to ensure food safety and to, you know, boost consumer confidence in the food that we eat, and also to make sure that there is adherence to the regulatory compliance. So the antibiotic residues are determined, you know, the major thing is sample preparation, which is simply like the process of isolating your analytes from the matrix. Then you also look at the cleanup and or pre-concentration, because the analytes that are found in this food or any other matrix that you'll be using, the analytes are available in very minute concentration. So pre-concentration is very important. So with the traditional extraction method, mostly liquid-liquid extraction and solid phase extraction are the ones that are used. But the problem is these have limitations because there's high volumes of solvents, and they're not so green solvents that are used, and they consume a lot of energy because there are multiple steps that are involved in processing these, the determination of these analytes. So as already stated by the previous speaker, the trend now is for the chemistry to go green. So in 1998, Anastas and Werner formulated the 12th principle of green chemistry. But unfortunately, like only 4 of them can adhere to analytical chemistry, which is waste prevention, use of safer solvents, which is number 5 on their list of their principles, and then using efficient energy, and then reduction of derivatives. So these are the ones that can directly apply to the analytical chemistry. So in 2013, Galuska and the co-workers came up with the concept of green analytical chemistry, and then they also formulated their own 12 principles. The highlighted ones are the ones that should be focused on to green the methods that we are working on. So with their method, we are looking at like the sample, the reagent that should be used, they should be green, the energy efficiency of the instrument, the waste reduction, and the safety of the operator. So if methods could adhere to these principles, then we are on a good track. So in order to, go along with the concept of green analytical chemistry, miniaturization has been the order of the day. So it was liquid phase microextraction is a miniaturized version of liquid-liquid microextraction, and it has different variants. For instance, the membrane-mediated liquid phase microextraction, which uses the hollow fiber liquid microextraction. We also have the most popular, the dispersive liquid-liquid microextraction. We also have the single drop microextraction procedure, and also they have their own variants. So the advantages of the liquid phase microextraction is that they work very well, just like with the traditional liquid microextraction. And the good thing is that there's reduced solvent use. You can use anything from 1 microliter to over 250 microliters of your solvent. They are cost effective, and there is not a lot of waste because you're using very minute volumes of your extraction solvent, and they're very fast. Then, before I go to my next slide, it should be mentioned that even though the volumes of the extractions that are used in the liquid phase microextraction, the solvents that are still used in some of these variants of these procedures are some of them are, especially with the dispersive liquid microextraction, are chlorinated solvents, even though they are very small, but there's a need to replace them. So we are now looking into greener solvents. There are various types of green solvents, like your supramolecular solvents, which is what I'm going to be talking about. You have your ionic liquids. You have your deep eutectic solvents, which are analogs of the ionic liquids. You have solvents like switchable hydrophilicity solvents, and then you also have surfactants that can be used in dispersive techniques or also non-detective techniques. So the criteria for green solvents is that they should have reduced toxicity, they must be easily available, they must be cost effective and biodegradable. So in our method, we looked into the supramolecular solvents, which are simply water immiscible liquids that are generated in two ways. The first one is the aggregation of the amphiphile producing the supramolecular assembly, and then this process occurs spontaneously. Then it's followed by conservation, and then this conservation is triggered by an external trigger such as pH adjustment or temperature change or even salt addition. So in our work, the focus or the aim of the study was to develop a method of determining the sulfonamides in tomato juice using supramolecular solvent. We started by synthesizing the supers. So one way of synthesizing supers is that you can use fatty alcohols or fatty acids in the presence of tetrahydrofuran and water. So this is where we started from. We started by synthesizing all these using fatty acids and then fatty alcohol under these conditions, and we were able to get our supra at the end of the day. Then we utilized that supra for our liquid phase microextraction, our matrix. Obviously, the aim was to determine the sulfonamides in tomato juice, but it must be noted that we first developed the method in water where we spiked, and then we added our supra 200 microliters, and then we vortexed that mixture. We got a cloudy solution. That is where there was a dispersion occurring, then followed by phase separation with the centrifuge. Then we got our supra, which was sedimented at the top of our solution. Then we injected into the HPLC system. Bearing in mind that our at the back of my mind, green analytical concept was the order of the day. So even with developing the separation technique, we wanted a method that's going to be effective, but also going to be not too long. So we looked into 4 analytes. These are our sulfonamides. So we managed to get a separation where the analytes were eluted in under 5 minutes. And then these are the conditions that we used. We used a gradient elution program. And then this is the column and the conditions that we worked with. So with the selection of extraction, as already stated, we looked into 4 different supras, Supra 1 and Supra 3, and then we were able to determine that Supra 3 was the one that worked best. Then we went with that. So our approach was 1 variable at the time. Then we also looked at the effect of temperature because with the liquid phase microextraction, our solvent is water immiscible. So for there to be a mass transfer from the aqueous phase into the extraction solvent, the analytes have to be unionized. So since sulfonamides are amphoteric, they have the basic and the acidic part. We worked and manipulated the pH to get them to be at a place where they are unionized. And then pH 5 was that pH that we worked at. So pH 5 was our optimum pH for the mass transfer to happen. And we also look at the extraction, the extraction volume. We started from 50 microliters to 300 microliters, and then our optimum was 200 microliters. Then we also looked at the effect of the sample volume. We looked at from 2 mils to 10 mils, and then 5 was the optimum that we observed. And then under optimized conditions, this is the analytical performance of the method. And then these are our LODs in tomato and the LODs in our water sample. And we also did a spike in recoveries in the tomato samples, and our recoveries were from 88% to 99.5%. Then after developing the method and applying it in the tomato juice, we looked at the green assessment. We used 4 matrix tools to assess whether the method was green or not. Method 1 and 2, which is analytical eco-scale and analytical greenness, were based on the entire analysis from sampling to the detection, while matrix 2, 3, and 4 were looked only at the sample preparation part. And according to our assessment, the eco-scale, which looked at the entire analysis program, declared our method to be green, while Agree Prep said that our method needs some modification for it to be completely green, even though the method is acceptable. But with the SPMS, the method was found to be acceptable and sustainable. And in conclusion, a method was developed for the determination of sulfonamides in green, in tomato juice, and then these are the conclusion.
Thank you, the moderator. Merci beaucoup. And thank you for your presentation. This is an exciting presentation. However, I need a precision from the title. When you say liquid phase microexpression, did you miss something? It is a liquid extraction or a liquid solid extraction? I will need a precision. And also, when you perform the analytical assessment, And did you use an internal standard to validate the performance of the analytical method? Thank you.
For this particular method, we did not use any internal standard.
Why?
Because we couldn't find any at this particular time, but it's something that we can work on in the future.
But usually when you set up an analytical chromatographic method, you have, and also you use an extraction, okay? When you need to validate the extraction, you have to put an internal extraction to have the percentage of yield. And also this is the same when you perform analytical separation by chromatography.
Okay, thank you very much for your presentation. Now we will, Dr. Fofana, Mamadou Fofana. Dr. Fofana will ask us with E for aryliden, dihydrofuran, 2,3 John, and E1 benzyl 4 aryliden pyridine 2,3 John as new electron file in enantiomer selective organocatalysis Michael addition. Dr. Fofana, we have 10 minutes for your presentation.
Thank you, Mr. President, for giving me the opportunity to present my communication, the title is E4 aryliden hydrofuran 2,3 diones and E1 benzyl 4 aryliden pyridine 2,3 diones as a new electrophile in enantiomer-selective organocatalyzed Michael addition. This work was carried between the Institute of Molecular Science of Marseille and the research group on bioactivity substance of the chemistry department of the Faculty of Science and Technology of UCAD. We present to you below the plan of this work. After this introduction, we have the synthesis of Michael acceptor, lactam, and Michael actosol, lactome. Then we present the synthesis of enantiomer-selective organocatalyzed Michael addition reaction with lactone and the synthesis of enantiomer-selective organocatalyzed Michael addition reaction of lactam. And we will end the conclusion and perspective. The synthesis of complex organic molecules by environmentally friendly process is a requirement for a modern society. Catalyst system gradually entered the field of organic chemistry and therefore had to be scientifically perfect. Currently, more and more applications are sought in enantiomer selectivity using chiral ligands, the synthesis of optically active product being a permanent challenge for cosmetic, pharmaceutical, and agrochemical industry. Nowadays, it is known that the enantiomer selectivity synthesis is very important because two enantiomers can have different biological activity. It's enough to recall the terrible story of thalidomide administered to pregnant women, which was sold in the 50s in the form of racemic mixture. One of the enantiomers have activity as a sedative, while the other have been shown to be teratogenic and causing a serious birth defect. And we show this picture, and we have a very defect for the baby. To avoid this, it is therefore important to synthesize an enantiomer product. The synthesis of Michael acceptor lactam, we have three steps. The first step, we have in condensation between acetophenone and derivative with oxalate, diethyl oxalate. And the second step, we have in aldolization with paraformaldehyde to give formaldehyde, and then in cyclization. And the last steps, we have reduction and dehydrogenation. So the first step, we try different we change the R, H, BR, F, and methyl. We have 4 products. So the percent give from 62 to 80%. In the second steps, we have so a good percent from 65 to 19%, and we have also 4 products and give a good yield. In the last steps, we have the reduction in this ceton, and then dehydrogenation, dehydrogenation, and we have the percent from 57.
I just wanted to add one thing from sort of my prior life. I thought this was a great presentation and love the questions from the audience, but I think something that's important to keep in mind is this evolution over the last several years that the FIT team has gone through, where they've really defined tools and approaches, and for many of these tools and approaches, they've developed manuals, they've developed procedures. All this is meant to be able to get a very awkward MCC system, figure out how you meet the world with the MCC system and get them to operate on the same terms so that a deal would be possible. So some of what's happened before, hopefully it won't happen again, because we've got new tools in place. And I think the other change in orientation, which is really important to keep in mind, is that I think there's also been an evolution in FIT skills and FIT orientation now that we're now in
We
the
have,
place where most FIT team members are
32
entering a compact development process, not
to,
saying, hey, what kind of fancy bell or
56.
whistle can I add to the Christmas tree? That's maybe a question that happened before. I don't know. But they're
synthesis,
entering the compact
for
development process saying, what is the
Michael
project
accepted
or
lactam.
program logic?
We have,
And how
who's
could
advanced?
blended finance
The first,
actually increase the scale and
advantage
impact
is,
of the regular MCC
this
interventions?
protocol
And so,
is
you know, it's a
like
pitch to work
to
closely
the
with
saving
FIT
steps.
team members and
And
keep them
the
on
second
target with that being a goal, right?
advantage
That they're there
is
to
the purification
support the
by
compact having greater
recrystallization
impact.
from ethyl acetate. So the synthesis of enantiomer selectivity organocatalytic Michael addition reaction with lactone. After the optimization, in this optimization we have catalyst screening, solvent screening, and temperature screening. And the use of the squaramide catalyst at 0 degree for 48 hours in dichloromethyl with 10 equivalents of nitromethyl remain our optimal condition for the continuation of our work. And we present here the schema of this reaction. The 4-arylden 3-cetonlactone, 1A and D, bearing electron with drawing or slightly electron donating substance like with nitromethyl A to E, to give the product 4AB and AD in moderate yield on and good enantiomeric access, and we have the entries 1, 3 in this table. We have a good enantiomer selectivity in 3 and 3. So, in contrast, the presence of the substance in nitromethyl had a beneficial effect in the reaction result, increasing the stability of the result Michael addition for BA to EA until 4 to 7. And the nitroethane 3B, phenyl nitromethyl 3C, and bromo or nitromethyl 3D, and ethyl nitroacetate 3E, all give the desired product in high yield. Just for selectivity was, and we show this in this table, and we have a good GR ratio, ratio just numeric, and we have a good AE and a good yield. So we have here the product for CA. We have a good DL, just numeric ratio, and we have the AE. We have EE, enantiomeric excess from 53 to 90%. and the yield from 54% to 90%. The synthesis of enhancer selectivity and organocatalysis Michael addition reaction with lactam. We present this reaction, and in this table we have a good yield and a very good DR and a good EE, XA, enantiomeric excess from 89% to 98%. And we present then here, we have 80 product and a good EE and a good percent and a very good DR up 20 and 1. We want to propose this mechanism of this reaction, lactam and lactone. This reaction started between the squaramide catalyst and the nitromethyl derivative. We can assume that the nitro alkane interact by double hydrogen bond with the squaramide, double hydrogen bond with the squaramide, and which allow it is easy deprotonation by the tertiary amine. Here, tertiary amine, deprotonation here, and by stabilization the nitronate ion. And the second step, we when the R substrate is present on the pronucleophiles, it is placed at the left side via an anti. That's time. Okay. Okay, we have this mechanism. Okay. In the conclusion, a total of then 10 Michael acceptor, we have 10 Michael acceptor lactam and lactone. So with Michael acceptor lactone and nitro alkane and as nucleophile, 7 compound could be synthesized with a very good yield up to 90% and good enantiomeric excess from 84 to 90%. Okay. You give me 1 minute. I want to present this perspective. Okay. One of the part of the laboratory research work will now be focused on the enantiomer selectivity synthesis of compound with dihydropyridine ring via an organocatalyzed Michael sequence, during which conversation a chirality central toward axial, and we have this according in this and we convert the axial, the central chirality to the central chirality to axial chirality. It is the perspective on this work. I want to greet some personality. Thierry Constancieux is a director of ESM2. He's ex-director. It is a teacher and it is a team of GRBS. Thank you for attention.
Okay, I think we will be on the third presentation.
Say, wait. Après naa la ko jox.
Okay. Okay. The title of your presentation is Application of Green Absorbance in the Removal of Malachite Green from Wastewater, Isotherm, Kinetic, and Toxicity Studies. You have 10 minutes. Jan is here.
You can use
Jan.
it if you want.
Okay.
So Dr. Aderi.
Okay, you can start.
Hello. 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 Hello.
Yeah, wait. Okay.
This
All
is
right,
also in my
so-
old life.
All right.
I just wanted to say that
Good evening,
unless
everyone.
access to finance is a
I am-
specific constraint identified in the constraint analysis, a blended finance intervention is not actually, it doesn't
All right.
have a goal around
My name
access to
is,
finance.
Aderi
The goal is
Bigbe Deborah
still
from
the goal in your
Ladoke
program logic,
Akintola
and this
University
is
of
just a
Technology,
mechanism
Ogbomoso, and I'll
to
be
actually
presenting
expand the scale or scope or
application of
impact
green
of what's already
adsorbents
in your
in
program
malachite green
analysis. So I
removal,
just didn't want there to be
isotherm,
confusion about that.
kinetics,
And also
and
to say that,
toxicity
you know,
assessment.
the issue of sustainability is a huge one for all of MCC programs, and I'm really glad Chris brought that up. Hopefully, as we get better at designing blended finance solutions, if we're really actually bringing the private
All right,
sector
so
into a sector
malachite
and they're
green is a
able to
dye
invest, and then that
has been
sector
used.
can grow on
That
its
is a
own, hopefully it will
synthetic dye
become
that is
more
being used
sustainable
in
because of a blended
textile,
finance
paper, and
intervention.
aquaculture
Now,
industries.
maybe some of them
And
aren't.
because it
And
is
it would be
known to
great
be
to
a
know that. And it would be great to learn over time so
mutagenic,
that we can improve our ability to
and
use
is very
blended finance to
mutagenic.
increase our
It's
sustainability
of
as well.
environmental concern. And because when it's leached into the environment, it causes so many damages to the flora and fauna in the water. So there is a need to remove them from the environment. Now, green adsorbents, as we all know, is an eco-friendly adsorbent, and because they are made from renewable, biodegradable materials, and then they offer a sustainable solution for water purification. They have high absorption capabilities, and they can remove pollutants such as dye, those malachite green that I'm using, and then the heavy metals and organic compounds. They are also very cost effective in that they can be produced from what we call waste from the environment, and this also make them an attractive option in water treatment application. In this study, I explored the use of Moringa oleifera seed husk that are being discarded as a waste to prepare a green adsorbent to remove harmful dye, which is malachite green, from wastewater. Through batch adsorption experiment, the investigation was of their isotherms, kinetics, and the toxicity assessment of before and after treatment solution were done. Now, the preparation of the green adsorbent, the moringa fruits, the dry fruits were collected, and then they were break open, and it was pulverized and ground. Part of it was treated with conc H2SO4 to increase the carbon percentage in the adsorbent. And then the final adsorbent that was prepared was characterized using EDX, SEM, FCR, and PHPZC. These were used to know the physical, chemical, and textural properties of the adsorbent synthesized. The Malachi green solution was prepared in the lab, and then the different solutions were prepared from the stock solution to observe, to do the batch adsorption experiment, and then the effect of factors such as adsorbent dose, solution pH, initial concentration, contact time, and temperature was studied, and the equilibrium data were obtained. Then analytical methods were used by reading the absorbance through UV visible spectrophotometer at the wavelength, that's 620, and to know the before and after. Then the calibration curve was obtained, and then it was related to the concentration, to know the residual concentration that will remain in the solution after the treatment. Also, the before and after treatment solution were subjected to toxicity assessment using allium cepa, that's onions, and then we're able to discover we were able to get the effective concentration at all, that's EC40, to determine the level of toxicity before and after treatment. Now the result, the SEM result shows that there are some pores on the surface of the adsorbent prepared, which after the treatment
private sector have kind of accepted this kind of this environment of high interest rates, and they're trying to figure out how to navigate within that space.
EDS,
and when we talk about blended finance, we're often talking about, well, how do we use grant financing to unlock
percentage
that,
of
whether
carbon
that's to
in
either
the
buy down the
seed
risk or
of
buy down the interest rate.
Also, the
but I think
result of
what the conversation that I've heard recently with the private sector,
infrared shows us that there are some functional group on the surface of the adsorbent.
They're looking for longer terms.
Facilitate what we call chemisorption. That's
what I've heard several times is you can
chemical
get a 30-year mortgage
between
on a house,
the adsorbate and the adsorbent. Also, the point of zero charge shows us that the point of zero charge, pH point of zero charge of this adsorbent is 5.6. Then the isotherm and the kinetics. The isotherm kinetics and the thermodynamic parameters, when they were evaluated, shows us that the process followed Langmuir isotherm model, which indicates there is homogeneous adsorbent on the homogeneous the process was homogeneous at the surface of the adsorbent. Also, the maximum absorption capacity when the solution, there are two solutions that are prepared just to know if there will be effects of other dye inside that Malachi green, and we discovered that there was increase in absorption capacity when it's of Malachi green when methylene blue was introduced. Also, the kinetics, the second order model, kinetic model, fitted the equilibrium data well, showing that the process is dominated by chemisorption. The thermodynamics, the values for the Gibbs energy, free Gibbs energy, shows that the process was feasible and spontaneous at all the temperature that was tested, and then the entropy shows that the process is exothermic. Okay, I've already explained this. So the toxicity assessment of the what's it called, the aspect of the toxicity assessment, we were able to discover that The process was non-toxic to the onion because there were root growths. That's the after treatment. But before the treatment, the EC40 was 12 ppm, while after the treatment, it increased to 22 ppm, meaning that there is a compatibility between the adsorbents and the adsorbate, and is safe to use. The key finding, in conclusion, the key findings we saw there is that there were excellent absorption capacity, and then the adsorbent was found to be eco-friendly and non-toxic, making it a sustainable solution for the water purification. The future research is still on removal of other pollutants or other dyes through this process, and then the scaling up of the treatment process, and work is also going on to know, because the toxicity assessment that was done is macro study, that is the study of the growth, the root growth, but then the microscopic study to know whether in the mitotic division there were aberrations. The study is going on that. And I would like to acknowledge my school, Ladoke Akintola University of Technology, Ogbomoso, Nigeria. I want to acknowledge the CSC, the Federation of African Society of Chemistry, Royal Society of Chemistry, RSC Toxicology Group, and the Inclusion and Diversity Group for this opportunity. Thank you.
Okay, thank you very much for your presentation. We take one question. Someone? No question? Okay, thank you very much. Thank you. Now we will
Go to you.
the next presentation by Yan Amar. The title of his presentation is Plant Nanofactory toward Green Synthesis of Inorganic Nanoparticles.
Yeah, I see. You can just press here, but I think this is, you can use this one.
Okay, so I have the opportunity to close the session. Thank you very much for the introduction. Okay, so I am Dr. Yan Amar from University Félix Houphouët-Boigny of Ivory Coast, and I'm working on nanoparticle, and precisely a non-metallic nanoparticle. That's why I made this precision on the title, as you can see it. So the first question we have to wonder is, what is a nanoparticle? If we look at this image, you can see the comparison of scale between carbon nanotubes, which is 100,000 smaller than strand of air. And also, if you look at the one house, which is the scale of 10 meters, you see that the air is also 100,000 smaller. So, if we have a deeper look on the scale, what we can think, what we can say, sorry, is that you can separate particles into two scales. I mean, two classes: microscopic one and nanoscopic one. And nanoscopic one belongs to this part. I mean, particles between 100 nanometer to 1 nanometer to 100 nanometer. And this particular size gives some new properties, some novel properties. So actually, it's not only a matter of size; it's also a matter of, novel properties due to the reduction of size, but also of shape and also of chemical composition. Synthesis of nanoparticle is quite difficult. First of all, the application of nanoparticle is almost in all kind of, all kind of application in life. As you can see, in coatings, drug delivery, electronics, optoelectronics, even energy, and you can have a variety of shape. You see from 0D to 1D, from 1D to 2Ds, and also, as we have seen this morning, some balls like this. And those multiple applications properties depend on the physical chemical characteristics of this nanoparticle. And to achieve this, to tune the physical chemical characteristics, so the properties, you have to control the morphology and also the size. So you need to find some new way to synthesize those nanoparticles. In the general case, there are two approaches. So the first approach is what is called the top-down approach. You start from the bulk material and you use some mechanical milling, some etching, ablation, sputtering. All of this is called physical method. And the other side, you have some chemical approach based on the bottom-up approach. So you start from some fluid, some solvents, with some precursors, some reactants. And as you see, you have some salt gels, laser, CVD, and also molecular condensation, and so on. The problem with all those approach is that they are quite complex synthesis. The cost also is very high, and you need to use some hazardous reactants, which means high toxicity. So in our cases, and also we have other problem here in Africa is that we lack of equipment, and we lack also of reactants. It's difficult to afford very costly reactants. So our idea in our lab was to find new way to synthesize nanoparticle from plants, from nature. I will show you some examples of work that have been done in the literature before showing our work. So, as we have seen before, green chemistry, green synthesis, or biosynthesis, or bio-assisted synthesis, actually all of this belongs to the environmental friendly synthesis. Among those synthesis approach, ones use the microorganism, bacteria, microbes, fungi, microalgae, and they use the extract of these biological substances, mix them with some metal salts, and due to the reduction of the metallic reduction, they can synthesize some nanoparticle. You can see also from the plant, all part of the plant can be used. For example, the roots, the leaves, the fruit, and so on. In the literature, you can find many examples of metallic nanoparticle, silver one, copper, gold, okay, iron, and so on. The problem with this metal nanoparticle is that they have very low stability. Also, you see that the plant dissolution is very has some seasonality. Also, you can't find this plant everywhere. Even in Africa, you have some place where you can find some plants and some no. And also, for example, for the microorganism, it's very difficult. I will show you one example of what we have done in our lab that has been already submitted. It's the case of zinc sulfide. So, actually, zinc sulfide is a very interesting model to study with the green synthesis. It possesses two crystalline phases, the cubic one, which is called the blend, and the hexagonal one, which is called Versit. It's a semiconductor with a very high band gap, so It can be used as an active photocatalyst. And most of its properties are guided by size, morphology, surface area, and defects. In general, the general synthesis are hydrothermal, chemical vapor deposition, thermal decomposition, and in most of the cases in the literature review, they have to use some sulfide sources as additional reactants. Okay, so we need, in fact, a facile, cost-effective, template-free method, and also suitable for large-scale synthesis of zinc sulfide with a very good dispersibility. So I will try to show you one approach. In Ivory Coast, we have one problem. So we have one environmental pollution, which is a seaweed, a brown seaweed called sargassum. In fact, we have two kinds of sargassum in Ivory Coast, nattans and fritans. You can find it on the seashore of the southern part of Ivory Coast. And this seaweed presents some very high toxicity for humans, fauna, flora, because of this H2S decaying during the decomposition. Also, recent research have shown that we can harvest more than 1,000 tons per year. So it's a very huge quantity, which made some very trouble for tourism. So I will try to present you the experimental condition and the characterization before discussing results. And this is a classical plan. In our cases, as I tell you, we developed a very simple approach to synthesize zinc sulfide. We used directly deionized water, so the solvent is water. We use zinc nitrate. We use directly the sargassum. We use HCl for the acidic condition, and NaOH for the basic one. And then we made some classical characterization to understand what happened. So the synthesis is very easy. We just extract in water, directly in water. We made some aqueous extract, as you see, at 70 degrees very easily. Then we mix it directly with the zinc nitrate, and we control the pH, we control the concentration, and the time and the temperature. So I will show you some interesting result now. After centrifugation and drying, we made some X-ray diffraction of the sample. For the sample synthesized at 0.2 mol per liters and at pH 7. And we obtain directly, this is the first ever reported synthesis of zinc sulfide directly from at low temperature. We obtain some blend zinc sulfide, as you can see with the peaks that has been indexed. We have also determined from this diagram the Debye-Scherrer crystalline size to be around 14.55 nanometers. We have made some SEM, sorry for the quality of image now. We have made some SEM, and we have seen that it's agglomerated particle with some sub-micron spherical one. We have performed also some UV visible spectroscopy to understand the role of zinc concentration. And what you've seen is that the change in shape and width of absorption band increased when the concentration was higher than 0.1 mol. And in the literature, we have seen that this was correlated to the nucleation of zinc sulfide. Also, if we focus on the duration time of the preparation, the synthesis, we have seen also the change in the shape and also in the absorption peaks for higher duration, more than 5 hours, and the formation of we attributed to the formation of larger zinc sulfide particles when the mixing time was higher. And when we change the pH from 3.3 to 10. We observe the blue shift as the pH increased. We know as zinc sulfide is a semiconductor, we know that we can deduce that as the pH increases, the band gap energy also increases, and we can determine this band gap from the Mott-Davis diagram, and we found some 4.06 EV at pH 10. So this is also correlated to the literature, since it means that crystal size was even decreased. So now we want to understand what happened during this synthesis. So to do it, we have performed some liquid chromatography, UV, and we have seen from the aqueous extract, four to five phytoconstituents in the extract. And the most interesting one was this extract at 2.4 minutes. Sorry, I'll go a little bit quickly. Okay. And we have seen that this peak disappeared when adding the solution, when adding the nitrate solution, the zinc precursor before mixing, and even during mixing, and even in the supernatant. Okay, so what we can say is that there is clearly one phytoconstituent in the sargassum extract that clearly binds the zinc and participates to the synthesis of zinc sulfide. So we want to analyze this. We have made some Molish tests, and we determined that this extract was composed of polysaccharides. And we also made some ICP, and we found that the sulfur composition was around 20.4 milligram per gram. So our idea, our hypothesis was that this extract was composed of sulfated polysaccharides. So what's the mechanism? We think that we know from the literature that when the polysaccharides are composed of sulfur, they are called fucans or fucoidans. And this is one kind of structure of fucoidans where we can see these sulfonate groups that could maybe interact in the synthesis of zinc sulfide. So we have succeeded to synthesize from a very direct and very easy process blind zinc sulfide nanoparticle, and we think that this is possible now to make a value of this because we have some very large amounts of biomass of seaweeds in Ivory Coast. Also, we think that the sulfated polysaccharides may act as a chelating agents of the metal cations, zinc, and also can be the source of sulfide for the nucleation of zinc sulfide. Okay, we still work on to isolate these phytoconstituents and to have more, information about the mechanism. Sorry for the delay, and thanks for your attention. Thank you.
Thank you. Thank you, my brother. As your friend of the same country, Côte d'Ivoire, I would like to friendly remember that it is forbidden to translate the name of our country. You cannot say Ivory Coast. You maintain Côte d'Ivoire. This has been forbidden for a long time by our authorities. Am I right?
You're right.
Thank you. And thank you equally for your good English. I'm proud of English. Thank you. You told about your material. You are in the nano field. We know that in this field, material costs very highly. And I see that in the characterization section, you presented many material. Did you manage to obtain all these results you presented us? I come from the same country with you, and I know how are our difficulties. I want to understand. Thank you.
Thank you, my friend and brother from Côte d'Ivoire. Okay, Professor. Actually, you are right concerning the characterization. This is the most difficult part of our work because nanoparticle is not. I mean, you need characterization. Fortunately, some of the equipments are available. I mean, in some laboratories, like in Mans, Université de Mans, you have some equipment. INP, Yamoussoukro, you have some equipment. Also, so you have some private company called Anval. You have some equipment. I made the HPLC at Institut d'Hygiène. You have some equipment. So I had to search a lot to find some equipment. And but actually, I'm working on for the HPLC MSMS. I'm working with some friend in China to have more, more deep information. That's great.
Hello. Thank you so much for this. The ZN by HPLC using UV detector?
Do you mean if it's possible to characterize the zinc with the HPLC?
Yes.
Actually, what we have done is just, you know that and the HPLC is based on the mobility of molecules. So what we have done is show you. We just use the solution of, the extract of zinc nitrate in water, and also the supernatant. And what we just seen is just the peaks associated with the constituents. But we cannot say if it is zinc or not. We just see that when adding zinc nitrate, the peak associated with the phytoconstituents disappear.
It's not possible. Huh? Merci.
No, it's not possible yet for the zinc, but for the constituents.
For the presentation, I just want to ask that the nanoparticle, did you characterize? Did you use TEM to? What was the size of the particle using TEM?
Okay, actually I have done some TEM. I didn't show it here. The size was below 30 nanometer. And you see, and also I didn't show here, but when we change the pH, we control also the morphology of the nanoparticle. We have some foil, we have some, the shape is like foil, or otherwise the shape is spherical. So we have two kind of, for the hexagonal one, we have foil, and for the Wurtzit one, for the blend one, we have spherical. So we are able to control the two phases at low temperature. We have done it, but I didn't show it here.
Thank you very much.
Thank you.
I think we have to wait those of Digitata, and when they come, we will do a technical talk of Dr. Clifford Chua. Is it right? Clifford, are you here? Ah, okay. But we wait a moment. The chairman is Prof. Hatem. It's a good duo. But it is a plenary. Shall we wait the others? Or? Yes, let us start the break.
It's time for.
Well, yes. Well, okay, so we go to coffee break, and then coffee break. Here.
It's in upstairs.
Que ce matin, oui.
Maintenant, est-ce qu'après on continue? Il y a d'autres présentateurs.
Oui, après il y a l'Éthiopien.
D'accord. Et pour les posters?
Bon, que les gens se passent.
Donc il y a plus un certain nombre de présentations des posters. Aujourd'hui, non, demain.
Les gens le font de façon informelle.
D'accord, vous voulez savoir parce que vous avez
For me, tomorrow I prefer to take your computer. Okay, no problem. No problem, don't worry.
No, I think I can use the laptop. Yeah, yes, because chemistry Africa we are required here. So I want to talk about. There are so many occasions to talk about. So here I want to chemistry Africa.
Yeah. No, because Clifford proposed to me to come to MPM, and I recommend him to come here first because it's a multidisciplinary conference. It will be more interesting to speak here instead of MPM.
Yeah, but I'm in Tunisia next month.
He will come the next month.
Yeah, next month.
You will propose a meeting for.
No, because I was telling her not long ago, because I think I want to do a different meeting.
No, because before that, I have to interrupt. I have to boost the editor-in-chief to be more reactive.
I'm going to have a meeting with a small group, not all the editors, a small group. And the idea is to talk about different things, then plan for the board meeting that we're going to have virtual, so that we can invite all the board members from all around the world, because that will be the first time. For Euro-Mediterranean, we did that at the site of a conference. It was okay because we had like 20 people online, but then the internet was a problem, technical issue. So I said, okay, maybe we should do a virtual one where we have board members from Brazil, from Asia, also joining for the first time. I think it would be good to tell them also what we've been doing as a journal. And maybe next year, if we do a board meeting, then we can try to do hybrid, where we do it at the side of the conference and we invite all these people. But then we have to look at the time as well. What time is best to invite somebody from Asia and somebody from Brazil to join? So I want to get as much board member as possible for the next meeting. But for Tunisia, we have a small meeting. C'est toi? Il faut que j'utilise ça. Ah, yeah, this works. Avant et derrière. Ouais. So.
And why we can see?
No, he will project it when he comes back. Yeah, I don't have so many slides. I have about 17 slides. So
Okay.
I don't want to keep people here longer than they want. Yeah, just most of this. It should be fine to tell a story about the journey.
Okay.
Yeah.
Good.
I always need my glasses. Sometimes I don't see what is there. I'm just going to
You can put diaporama. Huh?
Yeah, I will just look. Yeah, I will see. So it's fine.
So everything's okay.
Yeah, everything is fine. But how do I? Because sometimes when you're speaking here, it's too long.
Oh, you mean the sound?
The microphone, because you have to really.
Oh, okay. So let me see if I can bend it a little bit. Maybe this way.
Yeah, I hope so. Yeah, I hope
It's a little bit higher, but it's not
Yeah.
much.
Because most part of the morning there were people who were speaking and I could not hear them because I'm standing. Oui. Oui. Okay. Huh? Je ne sais pas comment ça sera. Yeah. It's the Basaya. Yeah. Tu rentres?
Hein?
Tu rentres maintenant?
Non, 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 pas là. Je vais rester parce que je fais partie du comité d'organisation du BRS. Au moins, c'est vous suivre quoi.
Tu es un étudiant?
Oui, je suis un doctorat.
Doctorat?
En co-tutelle à Sénégal et France. Je suis à ma troisième année.
Donc il faut que tu projectes ça.
Oui, ça.
Parce que ça, ce n'est pas. Yes. C'est mieux, c'est mieux.
You're from where?
Now I'm based in Pays-Bas. Yeah, but I'm originally from Cameroon.
Okay, from Cameroon. And you work for
Spring and Nature.
Spring.
Yeah.
C'est une poste que vous avez. Donc vous faites pas de la recherche pour vous?
Non. Avant, j'étais dans la recherche parce que j'ai fait mon doctorat là-bas, en Hollande. Mais maintenant, je travaille seulement comme éditeur pour Spring and Nature.
Et là-bas, c'est quand même bon.
C'est quelque chose de différent parce que je commençais comme scientific editor, ça veut dire que je lis les articles et tous. Mais maintenant, j'ai un programme Africa Middle East que.
Là, c'est un programme, par exemple, pour valoriser, dire.
Non, maintenant, je ne fais pas ça. Quelque chose comme. Ça va devenir peut-être 33 journaux dans ce programme. Comment on dit ça en français? Je les manage.
Ok, manage.
Yeah.
Okay.
Je travaille avec d'autres gens. Et I'm the leader of the African Middle East program.
Okay. And is it possible, for example, you have opportunity, for example, to help, for example, some people to go after PhD to have a postdoc, something like, for example, me, when I finish, for example,
you want to do a postdoc?
If you have some link or something.
Spring and Nature doesn't get it.
Okay, doesn't get it.
But maybe as an individual, because I know a lot of people.
Yeah.
I go to a lot of conferences.
Yeah, that's
I work with a lot of editors in chief. I know some people in France.
Yeah.
That run research institute. I know people in Qatar. I know people in Saudi Arabia. I know people all over Europe.
Yeah, because I have another.
So it really depends on what you're working on.
What do you? Yeah.
And if it's a topic that I know somebody that I can link you to, and that they're interested in you, I can always link you. Because I go to all these conferences in chemistry, material sciences. My background is not in material sciences. My background is really climate and chemistry.
In chemistry.
Yeah, climate and chemistry.
Okay.
So more climate change and air pollution and that kind of research. So I'm kind of out of place here, and because I don't see anybody talking about air pollution.
Yeah, I see.
So,
because for us, we work on environmental for detection or removal of hazardous pollution.
I think the secret is that before you finish your PhD, make sure you have some papers.
Yeah. I have one paper, but now I write my second paper.
Yeah. So you have to look for a good journal. Chemistry, I mean.
Yeah, chemistry.
Yeah, because if you publish in some of the core journals, then I have 2, 3. Then you stand a good chance for a postdoc. A postdoc in the US is an option. Because for me, I applied to one position in the US and I got it. And I was the only one who said, no, I want to go to England instead. So in the US, they have quite a lot of money. And there are a lot of opportunities for young Africans to do their postdoc. And having some good papers is a way to show that you have the level. Do you understand what I mean? Because some people just do doctorate and say, oh, I just want to get
I just want a paper.
Yeah, and that shows that I have a doctorate. But if to really enjoy that opportunity, you have to show that you have the level. It doesn't matter where you're coming from. If you can show that you have the level, and a professor in Holland or anywhere else can take your application and see this kid has something. Because that's the first thing they check. Looking from Africa, they say, okay, let me check his research. Then they start reading your paper. They take their time. They bring the paper.
Yeah, no. I know that.
Because they want to see the way you think.
What you do exactly. If it is interesting, something.
Yeah. Because there are possibilities, but you can always reach out to me, and you never know what I might do.
No, but because I have one professor in French.
Yeah.
Diana Emali is in Paris, University of Paris City.
Yeah.
I will have, after my defense, I will have two diplomas.
Yeah. Because I have another guy, Shehimi. Is his name?
Shehimi is in the same lab with me. Yeah. No, yeah.
So
in the same lab. Yeah, Shehimi. I know this guy.
Yeah.
He takes another one of my friends.
He works with a lot of African students. So,
he's a good guy.
Yeah. So he's an editor-in-chief. He used to be the editor-in-chief of this journal.
Yeah.
And now he's the editor-in-chief of Emerging Material. So that's the first person that come to mind. But
we are in the same lab.
Yeah. But if you work on material for renewable energy, I know this guy in Italy, Vincenzo, that we work on a journal together. And you never know. Yeah. Because I go to all these meetings, and I end up talking to a lot of people. Yeah.
No problem. I will see after my PhD.
Yeah. Because another thing can be you might meet a professor that doesn't have money, but then you can put together a proposal. That's also an option.
Because after you have it's so difficult after your PhD. You don't know what to do after. It's so difficult for the university to take you.
Yeah. So you have to
look.
Yeah, you have to go somewhere else.
Yeah. I think Europe or something is better.
Yeah. If you come back here, you come back at a level. Because now I still get involved in research, but not much. 2022, I was involved in a research project in Morocco for a year, but it's not part of my job. I just do it by the side. And now I'm working on a paper that we worked together when I was in Niger. I think that paper is almost accepted. So I do the small things, not because not because it's really important, but I just do it.
No, it's not. Because if you didn't go in Europe like this, you cannot now enough material or more application.
No, I think
here I think the research is so basic.
Yeah, I think in Europe, because I ended up as a modeler. Where will I model in back then? So it was something that was really not in Africa. Now you have a bit of it, but Yeah, it gives you opportunity. It opened the door for me. I went for my master's, I did my master's, then did my PhD, then moved around for postdoc.
In Netherlands?
Yeah, I did my master's in Netherlands and then my PhD there.
But Netherlands is so good. I think it's so good in Netherlands.
Yeah, it's relatively okay.
And they pay more. They pay something.
I think it's okay. It's okay. Maybe compared to France, it's better than France. So maybe. But life is also, it all depends. All these things are just add up because life can be expensive as well.
Yeah.
You never know. So it's a combination of different things. But it's a very small, quiet country. Yeah, nice place to live. Yeah.
Okay. Nice to meet you.
Yeah, nice to meet you as well. So maybe I give you my card.
Yeah, you give.
Yes.
Okay, thank you.
You can always get in touch with me. You never know what I know. If I don't know anything, I'll tell you I don't know.
No problem.
You never know. I meet quite a lot of people.
And this is your number?
Yes, that's my number, but that's my office number. It's better to send me an email. Yes, that's my email. Yeah. And it means I end up having you end up having something that you can contact me there directly. But are we gonna talk?
I think it's time to.
I want to talk about chemistry, Africa. Yeah. So
that's technical.
Yeah, technical. Yeah. I don't know if this talk is technical.
Yeah, I was told it's plenary. I'm looking for plenary also.
Yeah, it's just a talk about a journal that we published. Yeah, it's a journal we published in the Recent Chemical Society. Yeah, it's general. I think I would definitely be out of place here if it was the scientific one. Huh?
Okay.
I don't know what they're doing. I'm just waiting here. Yeah. What are they waiting for?
Yes, I asked for a professor to see.
Yeah, the mosquitoes.
They are waiting for the other room.
Okay, that's fine. So.
They finished now?
Not yet.
Not yet?
Yeah.
What are they talking about? Did you get my email? You got my email, yeah? Yeah, I sent you the email.
Right now?
No, we are waiting for the downstairs. That's fine. Okay. Yeah. It was an email that I sent to you. I don't know if I sent it to your professional email.
When?
Today, because you asked for my monograph. I sent it to you.
Yeah, of course, yeah.
Okay.
Yeah.
It makes it
I
easy.
already noticed. How easy.
They don't want to hear about Journal.
Because when we are playing in the morning,
Bonjour.
oui, enchanté. Ah, moi, Comment vas-tu? Ça va? Tu vas bien? Ah, le gars de Parisis, là. Oui. On a fait les études dans la même université en France.
En France.
Pendant j'étais à 89, c'est dans la même spécialité. Chimie industrielle ou chimie des polymères. Toi, tu étais en quelle année? 93, 94. Ah, d'accord, juste après, 2 ans après l'étude. 2 ans après. Mais normalement, oui. Moi, j'étais dans l'équipe de Paris 6, mais je faisais mes recherches au Collège de France avec Sylvie Boileau. Tu connais? Tu connais pas? Sylvie Boileau. Non, elle n'a pas d'enseignement. Emery travaille avec Sylvie Boileau. Moi, j'étais à Paris, ils sont tous morts. Marie-Chantal est partie. Comment il s'appelle? Oui, qui encore? Sylvain, je ne sais pas si. Et puis, il y a Yves Oran, il y a. Parce qu'il y a des quatre universités. Il y a des Normands, l'autre université, il y a des quatre. Tu vas essayer d'implémenter un peu
Ah, vous allez le faire forcément. Vous allez le faire, c'est juste que maintenant, salement.
Parce que si ils me disent que je viens de ce matin, c'est très bien de matin que je viens encore. Je pourrais arriver ici 8h du matin.
Vous prenez de partout? Vous êtes où ici à
70.
Vous n'osez pas donc, à Radisson ou bien...
Non, parce que c'était difficile de... Ouais, je fais ça un peu tard.
Ah, ok, plus tard.
Et
Ok, je comprends.
presque tout était pratique.
Après, ils ont dit...
Non, c'est pour ça que je t'ai annoncé à 100 000. Il faut que je prenne un taxi. Je ne sais pas comment je vais se déplacer, même si je prends un taxi.
Ok, super. Ok.
I kindly ask you to take your seat, please. So we will begin the first session of the last session of this hard first day of this conference. And it's my pleasure to introduce our friend and colleague, Dr. Clifford Chua. He's a senior publishing editor at Springer Nature, where he leads the African and Middle East program. Clifford studied earth and environmental sciences at the Vrije University in Netherlands, Amsterdam. He obtained his PhD in chemistry and climate for Wageningen University at 2015. His research focuses on understanding how sensible policies on climate and air quality can lead to co-benefits using integrated assessment model, atmospheric chemistry transport model, and Earth system model. And today, Clifford will talk about Springer Chemistry Journal and especially Chemistry Africa.
Thank you very much for the warm and kind introduction. And thank you very much for inviting me to take part in this conference. I think I'm really happy to be here to talk about Chemistry Africa, a journal that we publish in partnership with the Tunisian Chemical Society. And it's a Pan-African journal that we started in 2018 with the Tunisian Chemical Society. So I will talk today about this partnership, and I will share some ideas about how this has actually evolved over the last 6 years. So for the presentation today, I have some few things that I want to share with you. I will start by actually talking about the partnership that we have with the Tunisian Chemical Society, how it came about, and the idea behind it, and how it's actually evolved over time. I will also share some overview about the journal Chemistry Africa that we published. I will actually share also some results from our author survey, what our authors actually think about us. I will talk about the impact of the journal within the Chemistry Society in Africa and beyond. And I will end by talking about how the journal contributes to the Sustainable Development Goal. So, I think before I joined Springer Nature, Chemistry Africa is a journal that actually started before I joined. And it started in 2018. And the idea behind this, launching this journal, was to create a Pan-African journal for chemistry that covers a broad field of chemistry, create a home for African researchers to actually publish their work. So Springer Nature got together with the Tunisian Chemical Society to create such a journal. So the idea was to actually create a broad scope journal, as I mentioned, that cut across different sub-disciplines of chemistry. I will show you subsequently the different topics that this journal actually covers, but it ranges from theoretical chemistry to application. And we also, the idea from onset was also to focus on sustainable development, especially some of those goals that are really important for the African continent. And apart from being a Pan-African journal that actually aimed to attract submission from Africa, we also wanted to actually open the journal to the rest of the world, where researchers that are working on topics that are really related to understanding the African story can also submit and can also publish their work. So with that in mind, the journal is actually structured as follows. I will go through the structure of the journal just so that you understand when I actually move to other part of my presentation. So we currently have 3 editor-in-chief that are from the Tunisian Chemical Society that are actually leading the editorial process of the journal. We also have an honorary editor-in-chief who was actually the brain behind this journal at the early phase of this journal when we started, Mohamed Shihimi, who really contributed. I worked with him for a year or 2 when I joined Springer Nature and I started working on this journal. Also, I had the opportunity to work with Professor Atem, who was then the president of the Tunisian Chemical Society, and I think was also the brain behind the launching of the journal and was really, really supportive in the early days of the journal. There are so many other people that really contributed to the launch. Some of these people maybe I don't even know, maybe they are not part of the journal anymore, but if I don't mention them here, it's not because we've forgotten about their contribution to the journal, but we know there are so many people who contributed towards the success or what we've achieved so far. So I actually mentioned earlier on that it's a broad scope journal that covers different topics. So we have 5 main topics that we cover in the journal, ranging from organic, and Mohamed Lofi is actually leading the organic part of the journal. We also have inorganic, that is actually led by Francis, who is based in China. We have structural, analytical, and physical chemistry, which is led by Heinrich, who is based in Germany. We have functional and material composite, led by Aman, who is based in Canada, and also chemistry in society, who is led by Goffred, based in Ghana. So the idea was to bring people not just from Africa, but also editorial board members from the rest of the world that are also working on topics that are really relevant to us as African researchers. So this gives you a better picture of the whole entire editorial board, because what I just showed before actually relates to the senior editorial board member that leads the various topic. Here you can see where all our board members are coming from. You can see that we have really a global editorial board. We have people in the US, we have somebody in Canada, and then we have people from South America, from West Africa, from Northern Africa, Europe, and South Africa, and also different part of Asia. But if we look at the African map, we still miss people from East Africa. I think this is something we've been trying to look into. So if you're from East Africa, you're a researcher, and you're really interested in joining this project, please don't hesitate to get in touch with me, and you can become part of this project. So this map actually shows where our authors are coming from. You can also see that we have authors from all over the world, from North America, South America, from different parts of Africa. You can see maybe Central South Africa is missing a little bit, but we have quite a lot of authors from South Africa. Eastern Africa, we have quite a lot of authors as well, China. So we've created a journal that has not just visibility within Africa, but also have international visibility, where we can attract content from authors from different parts of the world. And I think this is really important for us as African researchers to understand to understand maybe some of the challenging problems within the continent from other researchers that are also working on similar topics in different parts of the world. So if you go to the next slide, you can see that since we launched the journal has actually evolved over time. The table above actually shows the number of submissions. In 2022, we had 850 submissions, but I think when we started, we had less in 2018. Then in 2023, it almost doubled in 2023 to about 1,500. And then this year, until September, we had already exceeded what we had last year. So the idea is that maybe we're going to get up to 2,000 submissions this year. So that's just to tell you that more and more people know about the journal, people are willing to submit to the journal. And below, you can see the bar chart below. The chart below actually shows the number of publications. It was over 250 in 2022, and then it increased to, well, I think most of the time it has stayed in around 250, 260. But this year we expect to publish around 300 papers because the submission has actually increased drastically. So with the increase in submission, we look at the time to first decision, you can see that it has actually also improved over time. I think we started with one editor-in-chief with Professor Shahimi, but now we've actually moved to 3 editor-in-chief to make things easy. So you can see that the time to first decision has actually improved as well, even though we are seeing more and more submission. So I'll go to the next section that actually gives us an indication what our author think about us. What we do is that we send survey to our author so that they can actually tell us what they think about us. This plot actually shows, like, on a scale of 5, how our author rate us across 5 different things that we think are important. We are talking about speed, we are talking about editorial communication, peer review, then external advice and management, production, and also online process. So if you see on average we score above 4 in all these different categories. So it means our author actually rate us relatively high. And you can see that if you compare 2023 to 2024, you can see that we do slightly better in most of the different categories, except in production. I think we had some problem in production at the beginning of the year. I think that might actually affect what we see here. And that's now resolved. So I hope maybe by the end of the year, maybe we see even an improvement in the way our auto rate also when it comes to production as well. So to look into it more further, you can see what our auto in general think about our service. You can see, I think maybe the figure is a little bit blurred on the screen if you don't have good eyes. But you can see that in 2023, a good proportion, actually, I think about 80%, they thought we were excellent. It went down to 75%, but you can see that 18% thought we were good in 2023, but 25% actually think we were actually good. So if we summarize this, 99% thought our service was good or excellent in 2023, and now we have 100% that think our service is good or excellent in 2024. So relatively, even though we see increase in submission, we see more and more, because we restructure the journal, the board of the journal, we see more and more better service that we provide to authors. So for researcher, it's also important, the impact of the journal is also important. Here you can see the number of downloads. If you actually look at this graph here, or this table here, you can see from 2022 that number of downloads almost double. And if you look at until September this year, we were close to the number last year. So we're definitely going to exceed the number last year by the end of the year. Even if you look at these numbers here in 2024, they're consistently higher than the numbers in 2023. So more and more authors are actually accessing our published content. They're downloading it, they're reading it, because as a researcher, that's what you want. You want your paper to be read, downloaded, and cited as well. So since we launched, I think the first time we got indexed was in Scopus was in 2021. And since then, the size score also has been going up since we got indexed in Scopus. So that's also good to see. Then the journal received its first impact factor in 2022. It was 2.6, but last year it went down to 2.3. But you can also see that if you look at the number of source items, it also went up from 202 to 306. So the number of source items went up, the number of citations went up as well, but the impact factor went down slightly. So based on the number of citations that we are seeing now, I expect that we will soon see an increase in the impact factor again, and hopefully the journal will have more impact. So I mentioned, I'm going to my last slide, that Sustainable Development Goal was also at the heart of, or sustainability in Africa was also at the heart of launching this journal. And it's really important to stress that it's also at the heart of what we do as a company, both internally and externally. So externally, how do we really want to contribute to the Sustainable Development Goal? We want to connect researchers with policymakers and also people in businesses that are really responsible for coming up with innovation or coming up with policies to actually try to address some of the challenging problems that we face. So how do we do that? We actually make sure our published content are actually shared or are made visible to really to different communities via a variety of channels. For instance, we have a deliberate marketing campaign to promote our Sustainable Development Goal content. So how is this journal doing in terms of Sustainable Development Goal? So if I go to the next slide. So you can see, I just went through just to see what Chemistry Africa is doing in terms of different Sustainable Development Goal. You can see how many papers we've actually published in relation to different Sustainable Development Goal. There are other ones that I didn't put here because maybe they were just few papers. But we publish across the a lot of the different Sustainable Development Goal. And the idea is to, how do we, because I've listened to a lot of presentation, and I can see that a lot of African researchers are working more and more on topics that are related to the Sustainable Development Goal. So we want to actually invite you to be part of this journey and share your content in this journal, because we really want to focus on this Sustainable Development Goal as well. So if I go to the next slide. So how, as researcher, how can you contribute to this Pan-African journal? You can contribute by submitting your own paper. I think we get a lot of submission from authors from Africa. It can be a review paper, or it can be just a regular article that you can submit. You can also reach out if you have a good idea, you're organizing a conference, and you think you want to open a special issue or topical collection. You can get in touch with me and we can discuss your ideas with the editor-in-chief and see if it's a good fit for the journal. And then you can really be responsible for your own collection and really contribute to the journal. You can also suggest potential board member. I actually mentioned that we meet some researchers from East Africa. If you're from East Africa or you know researchers from East Africa that can really contribute to the journal, please don't hesitate to get in touch with me and let's discuss and see if you can contribute to the journal. You can spread the word about the journal in your network. So I think we can work together to make this journal really a home for African researchers, because I think this is one of the first journals within Springer Nature that I think we have a lot of partnership, but in chemistry that we have with an African society. I think this is a good example of how we can partnership and really create home for African researchers to publish their work. Not just publish their work, but also take responsibility of their own work and try to attract content from other part of the world that can be relevant to them and to understanding their problem. I think together everyone can achieve and we can all benefit if we work together to make this journal a success and support the initiative of Tunisian Chemical Society and Springer Nature. So I think this is the end of my presentation. I know it has been a long day, so I'll try to keep it short. I hope I was short. Yes, there's a question already. I don't think I can hear you. Maybe you use the mic and it's easier for me to hear you. You can meet me in the hallway and we can talk.
Okay, thank you for the nice presentation of your journal. I'm the technical editor for the Tanzania Journal of Science, which is going to be. And you reward or keep your reviewers, because that is something also of a challenge in publication. Also, you talked about 300 papers a year.
Yeah.
How do you publish them? As they come, or do you have issues? We have 4 issues, and we don't manage 300.
Okay.
So how do you do that?
Thank you very much for the question. I think you're right that having the right reviewers who can really provide constructive feedback to papers is really important to what we do. I think for most of the journal across Springer Nature, we have a database that we use for reviewers. I don't think it's anything internal. I think we have the review finder that we use. And at Springer Nature now, we are building a new editorial system away from editorial manager, and this is actually embedded, this database is actually embedded in the system, which make it easier for our editors to find the right suitable reviewers. But I think over the last 6 years, we've also built a good database in the editorial manager. And if we ever move to a new editorial system, this is a database that we're also going to transfer to the new system. So we don't really have, I don't think, we might have problem finding the right reviewers, but I don't think it's a big problem. And then there was a second question about, if I remember correctly, number of publications, sorry about that. Yes, I think if you see our acceptance rate is still out of 2,300, so it's still relatively less than 20%, if I'm correct. 20%, yes. So I think, yeah, we publish across 10 different issues, because now we have 10 different issues. I think we have 8. The next year we're moving to 10. I have to check to be sure. But I think there's a possibility, the way this journal is actually evolving, that we go to monthly issue, because we receive a lot of content, and it's really important for authors to make sure that the paper get assigned to issue quick. So maybe when we meet in Tunisia next month, this is something we're going to discuss. We're going to discuss how maybe we can move to a monthly issue, or maybe continue article publishing, why not? And because that is much, much better for authors as well.
Mr. Clifford Chua, thank you very much for your talk. My question is, what Chemistry Africa can do for this conference? because at the beginning we were thinking about a special issue or something like that. Is issues, but how can you valorize and how the participants can publish maybe not a special issue, but what can be done?
Okay, yeah. Thank you very much. I think when you talk about us stopping with special issue, I think for certain journals. For this journal, I think we open to discuss, still discuss special issue. But maybe for this conference, I think there was a whole discussion that we can have a dedicated link, not link, but dedicated pathway in the editorial manager where the authors from this conference can still submit their work, and they can still, actually, if the paper get accepted, they can still include the footnote that it was part of this conference. I think we do that for some of our journals as well. I think the whole discussion, we went into it late, and for this journal, I think we also have a given amount of special issue that we publish a year. So I think for this conference, if we are thinking about it in the future, maybe we have to start the discussion a bit earlier, because I think it's a good opportunity for a lot of authors to publish their work, but also mid-career researchers who want to be part, to lead a special issue, to have that experience leading a special issue. I think that's something we can do.
It's not a question, it's just a kind request. So in Tunisian Chemistry Society, we're proud of Chemistry Africa. So I would to invite you to submit in Chemistry Africa. We need to stay the course. As I said in French, garder le cap. We have an impact factor of 2.3. So we should fight to keep this impact factor. So please, you can submit your works in Chemistry Africa. Or even if you don't submit the work, just consult articles, Chemistry Africa published articles, and sit to stay the course. I'm also editors with Professor Modou. I think Aziz Amini, Professor Aziz Amini, who isn't here. So please kindly request submit your articles in Chemistry Africa and sit Chemistry Africa. Thank you.
This one? Yeah, you can this if you want. Okay.
Okay. You want to move around?
Yes.
Okay. Okay, we have come to the end of our day in terms of oral talks. Firstly, thanks to all the speakers previously. It's been a long day, and our last presenter today is Professor Mokenen, who is affiliated to Addis Ababa University and also the Euraccess Africa in Ethiopia. He's going to speak to us about an interesting topic. I've had people asking about funding, about collaborations, and all these things that we are talking about today is about research. Research requires funding. So he's going to talk to us about unlocking research funding, networking opportunities, and also in Horizon Europe through Euraccess Worldwide Africa. Please, let us jointly, warmly welcome Professor Mokenen to give his talk.
Thank you, Professor, for your kind introduction. Before I start my speech, I would like to thank Professor Madou Afal and Professor Matasek for inviting me to this very special congress and conference.
My name is Yedelfana Satarge Mokonnen, as already mentioned by Chairman. I represent both my university, my society, as well as Euraccess Africa. I'm also a chemist, and currently I am the Vice President of the Chemical Society of Ethiopia. Can you listen to me? Yes, thank you very much. As much as possible, I'll try to speak very slowly so that you can catch most of my talking. So we provide opportunities for researchers and for graduate students who would like to study their PhD, their postdoc in Europe, member states, as well as in associated countries. And also research networking with researchers worldwide, including researchers in Africa and researchers based in EU member states. Yes, I'm one of the regional representatives to Euraccess Africa. I'm not the only one, but I have my colleague, Dr. Ahmed Malal, who is based in Tunisia. He's also an associate professor in computer science. He has been the only regional representative of Euraccess Africa since its establishment in 2022. As of January 2024, I joined the Euraccess Africa team so that we can do our best to reach out as much as we can to many researchers and institutions in Africa to get benefit of this, particularly Horizon Europe, is prestigious, very large European Union funding program for research and innovation, which is close to 100 billion euros. So, as I already mentioned, I'm from Addis Ababa University. I'm currently also Associate Dean for Graduate Programs. As most of you know, Addis Ababa University is one of the oldest and largest university in Ethiopia, which is founded by the King Haile Selassie I. He provided his emperor's palace for the university, particularly for the main campus of the university. And currently we have actually 17 campuses, including the College of Natural and Computational Sciences. And we have more than 10 colleges, 13 institutions, and 2 teaching hospitals. One of the largest hospitals in the country belongs to the university. And we are now 74 years old. I think next year we celebrate the anniversary of 75 years. And starting from September 2023, AU restructured itself as the first autonomous university in the country, which is research university. And currently it has more than 400 undergraduate and postgraduate programs. And we have more than 40,000 students in different programs and campuses. And the university has more than 161 professors, 400 associate professors, and more than 1,000 assistant professors. If you count it, more than 56% are assistant professor and above. 60% of the university students are undergraduate, and the rest 40 are postgraduate students. And in our college, we have 18 PhD programs, 27 MSc programs, and chemistry is one of the oldest departments and who has a master and PhD and an undergraduate program in the college. I think you know some of these people from Ethiopia, from Chemical Society of Ethiopia. The first person in the left, Professor Solomon Merete, is the current president of the Chemical Society of Ethiopia. Second, Professor Ahmed Mustafa, he's a department head for a long time of the chemistry. And I think most of you know Professor Jonas Jabure, who has been a member of the FASC, and I can see that from the document, he is also an international advisory committee of the FASC for a long time. Professor Shimelis, you have collaborated with him, and Professor Burhanu Abagas, he's the first founding member of the society in the Bulletin of Chemical Society of Ethiopia, and he's currently in Ethiopia and helping us a lot. As most of you know, Chemical Society of Ethiopia is one of the founding member of FASC, and the first FASC meeting has been actually took place in Addis Ababa some time ago. And we are happy that we also read back and join this 9th FASC meeting this time. So like previous presenters, I also would like to invite chemists to submit the papers to the Bulletin of the Chemical Society of Ethiopia. It's one of the oldest and a very good journal in the chemistry field. It has been almost for 40 years since publishing a chemist's output. And the impact factor is 1.54 and the volume is 38, and we currently publish 12 issues every year. And it's also open access journal and free for Sub-Saharan Africa there's no processing fee. So I'm glad to mention that we had 2 milestones. We celebrate the 40th anniversary of the Chemical Society of Ethiopia. As you can see, it's an old society, professional society in Ethiopia as well as in Africa. And very interestingly, we also celebrate the 100th issue of the Bulletin of the Chemical Society of Ethiopia. So this time, we are also conducting several workshops, several panel discussions, and we successfully had our annual congresses every time. But there was some issues previously, some of you may know. For 2-3 years, we couldn't able to manage these annual congresses, but now we came back and grow very, very good, and the CS is now shining again. Many youngsters also joined the society. These are some of the pictures from the recent panel discussions. Yes. So by profession, I am a physical chemist. I think I do a DFPT calculation. So I never heard so far about the computational chemistry, but I already met one person. I think he's going to present about computational chemistry. So it's my pleasure to collaborate with experimentalists to do some computational works together. I studied in Denmark during my PhD. I studied DFT, molecular dynamics, and very recently I also joined the machine learning, deep learning to material science field. I work on rechargeable batteries, lithium, sodium ion batteries, and again, metal oxygen batteries, redox flow batteries, where I specialize my PhD. Recently, we also work with my graduate students about fuel cell, platinum and transition metal alloys, single atom catalysts, and some other emerging 2D materials. We also work on heterogeneous catalysis for the dehydrogenation of liquid hydrogen carrier for some small molecules, and CO2 reduction, oxygen reduction reaction, oxygen evolution, hydrogen evolution reactions are most common reactions in emerging energy storage and conversion technologies. We also involve in solar cell research. So in computational chemistry, we need to have some computational facilities. Unfortunately, at the moment, we don't have really sufficient resource in our country. So we do have a remote access to these computational facilities abroad. We have access to the DTU. Denmark is a place where I did my PhD. We do have access to CFN biennial user facilities in New York, in the US. It's a very big resource. Myself and my graduate students do have access to this facility from remote, and we do advanced research, and we really publish in a good impact journals. And we do have also access to CHPC, which is located in South Africa for some of my graduate students. So we are really very happy to collaborate on these areas. These are research grants received so far, either as a PI or as a member of the project, including the ISPF UK, so it's a recent one, and ACTIS in Kenya, and so many other projects, including the European Union funding programs. So I think I'm the only Ethiopian in this conference hall. So it'd be nice to just highlight few things about the country. Ethiopia is, as you all know, is one of the country in the East Africa, and is the second most populous country in Africa, next to Nigeria. So I think Ethiopia needs to be well represented in this kind of big meetings. And it's one of the oldest country in the world. We have more than 3,000 years of civilization or history. So Addis Ababa is the capital city of Ethiopia, and we claim that it's not only for Ethiopia, it's also for the whole Africa, for the continent. And the headquarters of Africa Union is located in Addis Ababa. So Addis Ababa is a city for all of us. And Ethiopian Airlines, again, is a spirit of Africa, and we're proud of this. And I think many of you maybe used it when you come to here or when you transit to other countries. There are more than 145 destinations, and it has more than 79 years and wins multiple prestigious international awards. So Ethiopia is also the origin of humankind. As you know, in history, Lucy fossil with 3.2 million years old is found in Ethiopia. So it's in the sense that all of us are Ethiopian. It's not only me. So the other important thing is that the source of the Blue Nile is one of the, I think this is the largest river in the world, which connects many countries in Africa. And Ethiopia is the only country that never been colonized, and we celebrate the Victory Day every March 2. So it's again, it's among a few countries who have their own calendar, their own alphabet, and their own number. So according to Ethiopian calendar, this time is 2017, right? So if you live in Ethiopia, you'll be younger by 7 or 8 years. When I arrive here, I'm just getting older. So we are also very known in the long distance running. I don't know, I didn't meet any Kenyan here, but we always compete with Kenyan. Yeah, I also kindly invite you to visit some of these many World Heritage sites which are recorded or registered with UNESCO. We have this very nice building of 14th century. We have so many archaeological, cultural, religious, so many other things that are that can be visited by let's say you, when you have a chance to visit Ethiopia. If you also admire the mountains, national park with high altitude up to 4,533, 4,377, even you could find the endemic wild animals and many animals, and some also African most traditional tribes, especially in the southern part of the country. Yes, I was telling about the high places. Now I'm going to show you about the low places. Minus 45 meters below sea level. You can find this kind of amazing landscape, and also an active volcano that can be seen by your naked eye, the hot volcano. Yes, now let's be back to the title that's given to this talk, and I will try to summarize it as I'm not aware of this. I'm the last presenter. So, Euraccess Worldwide is an EU initiative which is supported by the European Commission, established in 2013, and now evolved and have 9 hubs worldwide. That means outside of Europe. One of the 9 hubs is Euraccess Africa. So it is an all-in-one networking platform and reliable source of information and ideas to help talented European and international researchers explore and develop careers and contacts in Europe and worldwide. All the services that we provide through Euraccess in all the 9 hubs, in all the national hubs, are free of charge. So we provide free access to research information. We provide opportunities for research funding and networking through Horizon Europe framework. We have MSA. MSA is a Marie Curie Actions, doctoral, postdoctoral, staff exchange, as well as ERC. It's an European Research Council grant. And most interestingly, we have African and Mediterranean initiative in Horizon Europe that actually attracts African researchers, including chemists, to actively participate. So this is the Euraccess Worldwide team, worldwide. We have in the US, we have in Latin America, in India, in China, in Japan, in Korea, and the like. So I would like to talk about this. I hope I'm getting rotation. So Horizon Europe is an extension. It's an extension to Horizon 2020. How many of you know about Horizon 2020? Can you please raise your hand? Excellent. Yeah, it's an extension to that, and they call it Horizon Europe. It extends from 2021 to 2025 with a total budget of 95.5 billion euros. It's a huge amount of money. So 26% of this total budget goes to Pillar 1, which is excellence science, which includes European Research Council. There are 4 different schemes. I will talk about them later. And there is a Marie Curie Skłodowska-Curie Action, which has also 5 different schemes and research infrastructure. In Pillar 2, we have a global challenge. And we have 6 clusters under this global challenge. Most of them are actually included in the morning presentation. If you remember, Prof. Ehud was mentioning. Almost most of them are listed here. Health is one of the priority of Horizon Europe. Culture, creativity, and inclusive society, civil security and society, digital industry and space, climate, energy and mobility, food, bioeconomy, natural resource, agriculture, and environment. So we were told that everything is chemistry, right? In the morning. Do you remember? So I think chemists can join in any of these cluster and form or included in the consortium and apply for these big grants and benefit out of this. So the sole evaluation criteria for Pillar 1 is excellence, the excellence of the principal investigator or the coordinator in terms of intellectual capacity, creativity, and commitment, and excellence in terms of the research project, the proposal, in terms of groundbreaking nature, ambition nature of the proposal, and feasibility of the research project. These are the sole criteria. And this year, chemistry, the Nobel Prize winner in chemistry, David Baker, is among these excellent scientists who has been involved in a couple of MSA projects. And so far, since 2012, 19 Nobel Prize winners are supported by MSA project. So in the European Research Council, there are 4 schemes, starting grant with about 1.5 million euros for researchers who have 2 to 7 years of research experience after the PhD. At least 2 years of research experience after PhD can apply for starting grants and earn 1.5 million euro for 5 years. In consolidated grant, you need to have experience 7 to 12 years after your PhD, and you'll earn up to 2 million for 5 years per project. For advanced grants, it's about 2.5 million. For synergy grant, it goes to up to 10 million. So it's really a huge grant. You need to look for collaborators in Europe or in associated country so that you can apply and benefit out of it. So these are some of the results. And so far, since its establishment in 2007, 24 European Research Council grantees from African countries. I think South Africa has been doing very well. In Horizon 2020, there were 6. In Horizon Europe, I think they got 1. So, and North African countries, Egypt, Morocco, Tunisia, Algeria, I think they have been doing very well in ERC grants. And most African countries need to really work hard to increase the number. So in many Korea, as I already mentioned, we have the doctoral networks for PhD study, we have postdoctoral fellowship, and we have staff exchange, co-fund, and MSA Citizen. The beneficiaries, the primary beneficiaries are EU member states, the legal entities in Europe and associated countries. I'm happy to mention that I met so many Tunisians here. Tunisia is the first, the only country in Africa which is associated to Horizon Europe. So the Tunisian researchers, innovators can directly apply, can be a coordinator for any project in Horizon Pillar 1 or Pillar 2, Pillar 3 calls. So it's really a good opportunity for other country researchers to collaborate with Tunisian researcher and apply again for this opportunity. So other countries can be associated partner to in Horizon Europe. So another result from Africa participation in AMSA is looks very promising. So far in Horizon Europe, we got 72 organizations, account for 91 participations, and we won 56 projects. Out of these, 29 are from staff exchange. This actually involves many researchers to go to Europe and to make a network and do part of their research there, and also do in their laboratory in Africa. In Horizon 2020, it's actually more than 150 projects who won the Horizon projects. So the South Africa is doing very well again with 288 participation during the Horizon 2020. So I also would like to mention the open calls that we need to, maybe we can consider to apply. One of them is the staff exchange. The deadline is 5th of February. So you need to consider this call. And we have also consolidated grants. The deadline is 14th of January. We have, I think, around 2 months. And another important maybe to consider is intra-Africa academic mobility. At least 4 African institutes need to come together and apply for this grant, when they also need to get one EU member state or associated country entity or organization to apply for the consortium. So the deadline for intra-Africa mobility is 13th of January. So I also invite you to go through EU funding and tenders portal. This website is a place where you find all calls for proposals. in Pillar 1, in Pillar 2, Pillar 3 is not yet released. So you'll get all the grant schemes that you probably interested to apply for it. So this is a very important portal, and it's a place where also you submit your proposal. You get information and you fill out the templates and you submit and see the progress of your application. So I also bring some important calls that chemists can apply recently. As I already mentioned, the staff exchange, it allocates about 99.5 million euros, and this project to give a grant for 90 projects, to fund 90 projects, which means approximately per project you earn 1.1 million. So still it is open, so I kindly invite you to go through it, and if you're interested, to apply and benefit. And the other I selected one is the ERC Consolidated Grant. It has more than 718 million euros and potentially provide for 400 projects worldwide. So per project, you could earn up to 2 million, which extends for 5 years. So this is another important call that chemists could apply. The other one is, as I already mentioned, Intra-Africa Mobility. The budget is 29 million and it's going to provide for 21 projects. Per project is about 1.45 million. So it's also a potential call that we could consider. And in the Intra-Africa Mobility, I have the video for the information in English. So I will can provide the YouTube link. The one most important call that we're actually looking for to be released, the topics to be released in April 2025 is the Africa Initiative. It's a part of the Horizon Europe, but particular focus is to attract African institutions. At least 3 African institutions, legal entities, comes together and apply with coordinator in Europe or in associated countries, which actually very interesting and also very promising. A lot of topics, a lot of money is allocated for this. It's a part of Africa Union and European Union cooperation. So the first initiative was, for the first initiative, it was allocated about 350 million. For the second, 300 million. And for the third, we can expect between 300 and 400 or maybe beyond that. So we'll listen about the topics and we'll listen about the amount of budget allocated very soon, early next year. So these are some of the tasks of Euraccess Africa. We manage our subscribers, our African Research Network, and we provide supports for Africa researchers. We provide information, we provide advice and assistance to researchers and innovators. We provide capacity building workshops. We invite experts in grant writing, experts in specific Horizon Europe programs with MSC, with ERC, with Africa Initiative, so that our researchers be informed, be proactive, and be connected. So these are some of the pictures, highlights our activities in the past 2 years. My colleague Ahmed Malal has been visiting Kenya, visiting Morocco, visiting South Africa, Egypt since 2022, and Rwanda, and I think this is in Kenya. Again, this is in South Africa. I think in 2023 alone, he physically visited 3 universities in South Africa and informed the opportunities to the researchers out there. Yeah, this is in Morocco. This is in Algeria. Yes, this is in Ethiopia before I joined Euraccess, and this is after I joined him. We had a very good workshop with more than 300 people attended this info session and practical session. We had also in Hawassa, in other city. I also participated in the Nigeria EU Innovation Day in Lagos this year, 4 months ago. And I'm sorry. And I had also a chance to attend MSA workshop and MSA tuning in Tunisia last month. This is last week. I attended Africa Leaks in University of Ilorin. This is actually the day before yesterday. I have been in Lagos, in Johannesburg, at the WITS University and meet Professor Kenneth Ozomena's group and discuss about possible collaboration between Ethiopia, South Africa, and UK. There was also professors from UK who collaborate with Prof. Kenneth and other team members. So again, after this meeting, we'll also travel to Kigali, Rwanda, to attend this kind of professional meetings and inform the opportunities in Europe to researchers in that professional. I'm about to finish. There are webinars. This is what I want to actually inform to my fellow chemists. Since it's very hard to reach to all universities, to all researchers in Africa, strategically we designed to organize webinars, online events, inviting the experts from the headquarters in Brussels. We invite previous fellows with MSc or ERC or Horizon. We invite experts in grant writing. We invite awardees, higher officials from government, from European Union, from Africa Union and the like. And we organize many webinars. And these are available in our YouTube channel. So I really encourage you all to visit our YouTube channel and get more adequate and reliable information about the possibilities. So for next year, we plan to physically visit these countries. I hope your country may be available here, most likely. If not, you can discuss with us and can arrange either online or physical events to tell about these opportunities. We plan again in Senegal, in French language. My colleague Ahmed Manal will physically present here with Dr. Laurent from EU delegation and many other people. It's around April 2025. Please save this date. We plan to travel to Ghana in June 2025, in Rwanda, in Kenya, Uganda, South Africa, and Nigeria, Tanzania, Burkina Faso, Ethiopia, Tunisia, Morocco, and Algeria. Two of us will travel to some of these countries. So I really invite you to visit our website and subscribe for free membership to get our flash notes that we send out every week with the opportunities for PhD, postdoc, and research funding, as well as networking opportunities with the researchers who are based in Europe and associated countries. We also send out newsletters every quarter so that you are be informed. And also invite you to follow us on our social medias, LinkedIn, Facebook, Instagram, and X account. We are very active in the social media and we provide the information we have. So this is what I would like to say to you guys. So there are so many opportunities. Also a section that helps you find collaborator, either researcher or institute in your field of specialization, so that you come up together and sit down, write a proposal and apply for one of these programs and get a benefit out of it. So there is a section for collaboration. So we communicate every information that we directly obtain from the headquarters in Brussels through our program coordinator and different European Union delegations in different countries in Africa, including in Africa Union that's based in Addis Ababa. So there are a number of events that are already passed, so you can get the presentations both in a PDF and also for oral presentation, recorded videos. And for the upcoming events, you can get the link for the registration for the upcoming events. So please join our Euraccess Africa community. We have more than 16,000 researchers, 16,000 researchers in our network who are informed about these opportunities through Euraccess Africa. So thank you very much. If you have any comments, questions, you can also send me as africa@euraccess.net.
Thank you, Professor Mukumen. Just to let you know, I'm a fellow Kenyan.
Nice.
It's just a little bit late and we are tired. I could have challenged you for a run. Okay. The floor is open for quick comments. Any comments with regards to funding? Collaborations?
Yeah, I will be staying here until the end of this workshop, so you can also talk to me and we can also discuss about anything that you need to discuss with me.
If there's no further comments or questions, as you said, it is available. I just want to thank you once again for all your patience. I'll wish to invite the local organizing committee. Maybe they will have one or two things they need to share with us. Thank you again, everyone.
Thanks to all, and we are very sorry for the length of this first day. Tomorrow it will not be the same because we have all in order, inshallah. Inshallah. So we can leave. Today is a free day. I think everyone can go to where he wants to take his dinner. If there are some persons who have problems to find where to dinner or how to dinner, how to pay a dinner, something like that, they can contact us and we can help. Thank you very much and see you tomorrow.
Thank you very much.
Aziz Amin is here.
Aziz
Amin is here. There are buses. The buses will take you to the university guest house for those who are going there.
Yeah, you can take it. Or take this one. Take this one. Take this one. You have a lot. No, take that. We have a lot. Xaama tur ndox ñu dem ah. ordinateur bi yaakaar bu gaay la xam nañ bu gaay waaw foofu laa jëm foofu borom nga jëm ah.
Good morning, everyone. My name is Joel. I'm Mr. Kalia Pejusuda. I'm working with Miana and Marina Bukani. I'm honored to.
Demain matin, dañ koy utiliser.